Hello everyone, in this video we're going to explore topic 8.1 average value of a function on an interval. Now, the mean value theorem for intervals. If the function f(s) is continuous on the closed interval, then there exists a number c in the closed interval a and b such that interval from a to b of f(s) ds equals f of c times b minus a. Now, if you divide both sides by b minus a, you're going to get this one right here. Alright, now we're going to demonstrate the mean value theorem for intervals using the symbol below. Alright, the graph of the function f(s) equals negative 1/2 s squared plus 8 is shown below. Alright, now if you calculate the interval from 0 to 4, right? 0 here, 4 here, of the function negative 1/2 s squared plus 8 ds using the calculator, the answer must be 21.3, right? Now, the right hand side right here, if you pick a value c between 0 and 4. So for example, I'm going to pick the points right here. Alright, so c equals 2.3, right? And f of c equals 5.3, right? Why? Because you're gonna calculate f of c, which means f of 2.3 is gonna be negative 1/2 times 2.3 squared plus 8, right? So it's approximately 5.3, right? Now you're gonna take this value, you're gonna multiply by b minus 8, which means 4 minus 0, right? So it turns out to be approximately 21.3, right? Now, the average value of a function. If the function f(s) is integrable on the closed interval a and b, then the average value of the function f(s) on that interval is 1 over b minus a integral from a to b of f(s) ds. Alright. Now, let's take a look at the first example. Let f(s) be 12 times s times e raised to the negative s. Find the average value of f(s) on the interval 2 to 5. Alright, so this one is A, this one is B, right? So you have the formula 1 over B minus A, the interval from A to B of f of s ds, right? So it could be 1 over 5 minus 2, interval from 2 to 5 of 12s times e raised to the negative s ds, right? Now you're going to bring up the calculator, since this one is the calculator active problem, right? Alright, you're going to hit menu, calculus, interval from 2 to 5 of 12 times s times e raised to the negative s, right? ds. Alright, now right here it's gonna be 1 over 5 minus 2, which means 1/3, right? And hit enter. It's right here. You need to convert this one to decimal, right? So it's gonna be menu, number, convert to decimal, hit enter. The answer is 1.46231, right? Now, question B. Find the number c such that average value of f(s) is equal to f of c, right? So you have f of c equals this one right here, right? Which is this guy right here, 1.462, right? But the function f of s is right here, right? So substitute c for s, right? So you have 12c times e raised to the negative c equals 1.462, right? Now you're gonna print up the calculator. You're gonna hit on right here, go to the main screen, right? Hit graph right here. You're gonna input the first function, which is the left hand side right here. It's gonna be 12 times s times e raised to the negative s, right? Hit enter. It's gonna be right here, right? Now the right hand side right here, which is the horizontal line, right? So you're gonna hit tab, right? Hit 1.462 and hit enter. Alright, now you need to find the intersection, the interval 2, 5 right here, right? So you need to limit the domain, right? So you need to hit menu, number 4, window setting right here, s equals 2, s max equals 5, right? Hit OK. It's gonna be right here. Now you need to find the intersection between these two graphs, right? So you're gonna hit menu, number 6, number 4. Alright, move your cursor to the left, move your cursor to the right, then the intersection right here. C equals 3.3, right? Now let's move on to example number 2. Example number 2 is similar to example number 1. Alright, I'm gonna leave this one for you to practice. I'm gonna provide you with the key. The answer key for question A is 16. Now, answer key for question B, you have two values of C. C1 equals 8 over 3. And C2 equals negative 2. Now, remember, your domain is from 1 to 4, right? So you need to eliminate this guy. Your answer must be this guy, right? Now, let's move on to example number 3. The cows on a small dairy farm in northern Indiana are milked in the morning during a 2-hour period. Milk from the cows is pumped into a storage tank, and the volume of milk in the tank at time t is modeled by a strictly increasing twice differentiable function m, where m of t is measured in gallons and t is measured in minutes. At time t equals 0, there are 300 gallons of milk in the storage tank, which is right here. Value of m of t's at selected times t's are given in the table below. Now, question A. Estimate m prime of 70. Indicate the units of measures and explain the meaning of your answer in the context of this problem. Alright, so basically you're going to use the mean value theorem, right? You know that 70 is between 50 and 90, right? So you have m prime of 70 equals m of 90. Subtract m of 50. Divide by 90. Subtract 50, right? Now m of 90 is 3360, which is this guy. Subtract m of 50 is going to be 1640 over 90 subtract 50, right? 3360 minus 1640, then you divide by 40. The answer is 43 gallons per minute. Alright, now you need to explain, so you need to say that the amount of milk in the storage tanks is increasing because this is positive, right? By 43 gallons per minute at time t equals 70 minutes, right? Now let's move on to question B. Use the data in the table to evaluate the interval from 0 to 120 m prime of t dt. So we have the interval from 0 to 120 of m prime of t dt. It's going to be m of t evaluated from 0 to 120 by the fundamental theorem of calculus, right? Remember, we have integral from a to b of f of s ds equals f of s evaluated from a to b. So it's going to be f of b minus f of a. Alright, so keep that in mind. So you have m of 120 subtract m of 0, right? But m of 120 is 4250 and m of 0 equals 300, right? And it's going to be 3950 gallons, right? Now, using the correct units, interpret the meaning of this guy right here in the context of the problem. So you need to say that 3950 gallons of milk have been added to the storage tanks from t equals 0 to t equals 120 minutes. Now let's move on to question C. Use a right Riemann sum with 4 subintervals indicated by the data in the table to approximate this guy. Alright, now we're going to look at the table right here. 4 subintervals. So from here to here, 1. From here to here, 2. From here to here, 3. And from here to here, 4. Right? So we have 1 over 120. Interval from 0 to 120. M of t dt equals 1 over 120. Right? Times, since we use the right Riemann sum, so we're going to look at the right one right here. And the width is from here to here 20, right? The width right here 30. This could be 40. This could be 30, right? And the height is right here. Right? So we have 20 times 780. Right? Plus 30 times 1640. Plus 40 times 3360. And the last one, 30 times 4250. Alright, now I'm going to bring up the calculator. You're going to input this expression on the calculator, right? Then you hit enter. You're going to convert this one to decimal. Hit menu, number, convert to decimal. Hit enter. The answer is 2722.5. Alright. Now explain the meaning of this expression in the context of this problem. And you need to say the average number of gallons of milk in the storage tank from t equals 0 to t equals 120 minutes is approximately 2722.5 gallons. Now we need to answer this question. Does this approximation overestimate or underestimate the exact value of 1 over 120, the interval from 0 to 120 of m of t dt? Explain your reasoning. You need to say that this approximation is an overestimate because we are using a right Riemann sum approximation on a function m of t that is increasing on that interval. Look, the given function is strictly increasing, right? Now let's move on to example number 4. This is the AB Calculus AB BC 1999 free response question 3. The rate at which water flows out of a pint in gallons per hour is given by a differentiable function r of times t. The table above shows the rate as measured every 3 hours for 24-hour period. Now, question A. Use a midpoint Riemann sum with 4 subintervals of equal length to approximate the interval from 0 to 24 of r of t dt. Using correct units, explain the meaning of your answer in terms of water flow. Alright, so this one is the midpoint Riemann sum and 4 subintervals. Right? So you see that the first interval should be right here, right? The second interval should be from here to here. The third interval should be from here to here. And the last interval should be from here to here, right? Now we need to find the width. The width is going to be 6 times, right? And the height should be the midpoint right here, right? It's going to be right here. From here, it's going to be right here. This guy, right here. And this guy, right here, right? So, the interval from 0 to 24 of r of t dt equals width times height, which is 10.4, right? Plus 6 times 11.2. plus 6 times 11.3 plus 6 times 10.2, right? I'm going to print up the calculator. Alright, so I'm going to factor 6 out, right? So I have 6 times parenthesis 10.4 plus 11.2 plus 11.3 plus 10.2, right? Hit enter. The answer is 258.6 gallons, right? I need to explain the meaning of your answer in terms of the water flow. You need to say that this is an approximation to the total flow in gallons of water from the pipe in the 24-hour period. Now let's move on to question B. Is there some time t from 0 to 24 such that r prime of t equals 0? Justify the answer. Alright, so we're going to use the mean value theorem, right? Now, by the mean value theorem, we have r prime of t equals r 24 subtract r 0, right? Over 24 minus 0, right? Now, to get this one equals 0, right? It means the numerator right here must be equal to 0, right? So you need to conclude that r24 minus r0 equals 0, right? Then I'm going to add r0 both sides. So I have r24 equals r0, right? Now we need to check to see if this one happens, right? So we look at the table right here, r24 and r0. r24 equals 9.6, r0 equals 9.6, yes. The mean value theorem guarantees that there exists a number t between 0 and 24 such that r prime of t equals 0. Now let's move on to question C. The rate of water flow R of t can be approximated by Q of t equal this one. Use Q of t to approximate the average rate of water flow during 24-hour time period. Alright, now average rate is the keyword, right? So question C, we have average rate of flow equals 1 over 24 minus 0. The interval from 0 to 24 of this one right here, right? then you're gonna hit the calculator, right? So you're gonna hit menu, calculus, intro, hit enter. Now don't forget to divide by 79, right? So you need to divide by 79. So the answer must be, you need to convert this one to decimal, right? The answer is 10.7848, right? Now let's move on to example number 5. AB, calculus AB 2004, free response question 1. Alright. Traffic flows is defined as the rate at which cars pass through an intersection measured in cars per minute. The traffic flow at a particular intersection is modeled by the function f below, where t is measured in cars per minute and t is measured in minutes. Alright. Question A. To the nearest whole number, how many cars pass through the intersection over 30 minutes period? Alright. Now remember, this one is the rate, right? So when you take antiderivative of this one, you get the number of cars, right? So question A right here, you have interval from 0 to 30, right? Because it say over the 30 minutes period, right? From 0 to 30 of 82 plus 4 sine t over 2. Alright, now you're gonna bring up the calculator. You're gonna hit menu, calculus, intro from 0 to 30 of 82 plus 4 sine of t over 2, right? Which means s over 2. Right here, you're gonna put ds, hit enter. Right, now you need to convert this one to decimal, so hit menu, number, convert to decimal, hit enter. Alright, now question B. Is the traffic flow increasing or decreasing at t equals 7? In order to know if the traffic flow is increasing or decreasing, we need to take the first derivative of this one, right? So we have f prime of t equals derivative of 82 equals 0, right? Derivative of this one, we need to use the formula sine u prime equals u prime times cosine u, right? So it's going to be 4 times 1/2 times cosine of t over 2, right? Now we're going to substitute 7 for t, so we have f prime of 7 equals 4 times 1/2 is going to be 2 cosine of 7 over 2, right? Now you're going to bring up the calculator. You have 2 times cosine of 7 over 2. Hit enter. Convert this one to decimal. Hit menu, number, convert to decimal, hit enter. The answer is negative 1.872, right? Which is less than 0, right? So if it's less than 0, you need to say that the traffic flow is decreasing at t equals 7. Now let's move on to question C. What is the average values of the traffic flow over the time interval 10 to 15? Right? This question very simple, right? So we have the interval from 10 to 15 of f of t right here, which is 82 plus 4 sine t over 2 dt. And don't forget 1 over 15 subtract 10 right here, right? Because this one is the average. I'm gonna hit the calculator. So 1 over 5, right? Times the interval from 10 to 15 of 82 plus 4 times sine of t over 2, which means s over 2, and ds right here. Hit enter. Now convert this one to decimal. It's going to be 81.899, right? The units right here should be cos per minute. Now let's move on to question D. What is the average rate of change of the traffic flow over the time interval 10 to 15 minutes? Now, you need to know the difference between question C and D. Question C is say the average value, right? Question D, the average rate of change, right? So the average rate of change is going to be, remember, f of b minus f of a over b minus a, right? So keep that in mind. A equals 10, b equals 50 right here, right? Now f of b is going to be this one right here. So we have 82 plus 4 sine of 15 over 2, right? Minus 82 plus 4 sine of 10 over 2, right? Over 15 subtract 10, right? So it's going to be 82 subtract 82 is going to be 0, right? So I have 4 times sine of 15 divided by 2 is going to be 7.5, right? Subtract factor for out is going to be sine of 5, right? Over 5, right? So I'm going to bring up the calculator. So I have 4 times sine of 7.5 subtract sine of 5, right? Hit enter. Then you need to divide by 5. Hit enter. The answer is 1.517, right? Unit should be cos per minute square, right? Because the unit of the function f of t right here is cos per minute, right? Then you divide by times right here, which means divide by minute. That's why you have minute square right here, right? We're going to explore topic 8.2, precision, velocity, and acceleration using intervals. Hopefully, you recall some of our discussion about the concept of the particle motion from Unit 4 last semester. Now, we have added the ability of using iteration to our toolbox. We can do so much more with this idea. Recall that in our study of particle motion, a particle moves along a horizontal line so that its position at time t for t greater than or equal to 0 is given by s of t, or oftentimes s of t like this, velocity v of t, and acceleration a of t, right? Now, let's take a look at this example. Your teacher moves along a straight line at the front of the classroom according to the values in the table below. Time is measured in seconds and s of t is measured in cubic squares. Question 1. How far was your teacher's ending position from his starting position from t equals 0 to t equals 4 seconds? Alright, so you need to find the displacement between the ending position and starting position, right? So you have s of 0 right here equals 2, right? Now s of 4 equals 18, right? Now you need to take s of 4 subtract s of 0. It's going to be 18 subtract 2. It's going to be 16 cubic square. Alright, question 2. What is the distance your teacher travel from t equals 0 to t equals 4. Alright, so you need to calculate the absolute value of s from 0 to 1 first, right? S of 1 minus S of 0 is going to be negative 2 minus 2, right? Absolute value of negative 2 minus 2 is going to be 4, right? Now, from 1 to 2, you have S of 2 minus S of 1, right? It's going to be absolute value of 0 minus negative 2, which means 0 plus 2, right? It's going to be 2. Next, from 2 to 3, it's going to be S of 3 minus S of 2, right? Equals absolute value of 2 minus 0. It's going to be 2. Next one, from 3 to 4, S of 4 minus S of 3 equals 18 minus 2. And it's going to be 16, right? Now you're going to add all up this guy, this guy, this guy, and this guy. So it's going to be 4 and 2 and 2 and 16. The answer is 24 cubic square. Now let's take a look at example number 1 right here. Particle motion with technology. Alright. This one is calculator active. Alright. A particle moves along a horizontal line for t from 0 to 8. The velocity of the particles is given by v of t equals this guy, and the position is given by s of t. It's known that s of 0 equals negative 3. So this one is the starting position, right? Now, question A, find all values of t in the interval 4 to 7, for which the speed of the particle is 5. So, remember, when we talk about the speed, we talk about the absolute value of v of t, right? And this guy must be equals 5, right? Now, we're going to bring up the calculator. We need to store the function right here so that it's going to help us to calculate B, C, D, right? So we're going to add calculator. Alright, so you're going to hit V of. Now in this situation, I'm going to use the variable S because I'm going to graph V of t on the x and y coordinate plane later, right? So I'm going to use S as the variable. It's going to be the same thing, alright? Then you're going to hit Control and the button right here. Alright, so instead of t, I'm going to put s minus 3 times natural log of s plus 2, right? Plus 2 times s times sine of. Now I'm going to hit the fraction right here. I'm going to pick this one, right? It's going to be s squared over 12. And I'm going to hit enter. Alright, I'm done. Alright, so basically I need to graph this guy and this guy on the same x and y coordinate plane, right? So I'm going to go to home screen, hit graph right here. F1 of s actually absolute value of v of s, right? So I'm going to hit the button right here to pick the absolute value side right here. Alright, so I'm going to put v of s. I'm going to hit enter. Excavate right here. Alright. Now the second one is 5. I'm going to hit tab right here. I'm going to put 5. I hit enter. Excavate horizontal line right here. Now I need to restrict the domain. The domain should be 4 to 7, right? So I'm going to go to menu, window zoom right here, window setting. S minimum should be 4. S maximum should be 7. Alright, hit enter. Alright, so I have two intersections right here. This guy and this guy, right? So I need to hit menu, number, set intersection right here. Alright, move to the left of intersection, move to the right of intersection. It's gonna be right here, 5.62, right? Now I'm gonna do exactly the same thing for the second one right here, right? So I'm gonna hit menu, number set, analyze graphs, intersection, move to the left, move to the right. The answer is right here, 6.52, right? So I have two values, t equals 5.62 second and t equals 6.52 second, right? Now, question B. Write an expression involving an integral that gives the position s of t. Use this expression to find the position of the particle at time t equals 3. Right? Now, you know that the starting position is s of 0 equals -3, right? So you have s of t equals the starting position is going to be -3, right? Now you need to ask something. How do we find this one? Actually, we're going to take antiderivative of this one, right? So because antiderivative of v of t is actually s of t, remember? So it's going to be integral from 0, right here. You see that? To t. We don't know t, right? Of v of s ds, right? Now we're going to use this one to calculate the position at time t equals 3, right? So we have s of 3 equals -3 plus the integral from 0 to 3 of v of s ds, right? So since you already saw the function, right? V of s right here. So you just calculate s of 3 using this one, right? So I'm gonna go to home screen, right? Hit calculate right here, right? So I have s of 3 equals -3, right? So I have -3 plus, right? The integral, I hit menu, go to calculus, integral right here, right? From 0 to 3 of v of s ds, right? Hit enter. The answer is right here. You need to convert this one to decimal, right? So hit menu, number, convert to decimal, hit enter. The answer is right here. -6.26295, right? Now let's move on to question C. Find r times t in the interval from 0 to 8 at which the particle changes direction. Alright. Now remember that the particle changes direction when the sign of v of t changes, right? We need to get the function v of t, right? So we're gonna bring up the calculator. We need to hit home screen right here, hit graph, right? Now I need to clear this one, so I hit tab and hit the upper arrow right here. I go to F1 right here. I need to remove absolute value sign, right? So it's gonna be like that, right? So I need to hit v of s. That's it, right? Hit enter. It's gonna be like this. Now I'm gonna hit tab again. I go to F2 of s right here. I need to uncheck this one, right? So my function should be right here. Alright, remember that the domain from 0 to 8, right? So I hit menu, go to the window setting right here. It should be 0 to 8. Hit OK. It's gonna be right here. Alright. Now observe that v of t changes direction when t equal this guy and this guy, right? Because for the part below the x-axis right here, it's gonna be negative. The one above the x-axis is gonna be positive, right? So it could be from negative to positive, which means it changes direction. And from here to here, positive to negative right here, it changes direction right here, right? So I need to find the zeros of the function v of s. That's my answer, right? So I need to hit menu, number set right here. I need to find 0, right? So it's gonna be right here. I have the first zero, 2.34, right? I need to do the same thing for the second one, right? So hit menu, analyze graph, 0, it's going to be right here, 6.13, right? So you need to say that the particle changes direction when the sign of V of t changes, right? Then on the interval t greater than equal to 0 less than equal to 8. This occurs at t equals 2.34 and 6.13, right? Now let's move on to question D. Is the speed of the particle increasing or decreasing at time t equals 7? Remember, you learned from unit 4. If velocity and acceleration have the same sign, the speed is increasing. If the velocity and acceleration have opposite sign, then the speed is decreasing. Alright, so keep that in mind. Now, I need to calculate V of 7 first, right? So I'm going to use the calculator right here. I already have the function V, right? So I need to go to home screen, hit calculate V right here, right? So right here I just hit V of 7, right? Hit enter. The answer is right here. I need to convert this one to decimal, right? So I hit menu, number, convert to decimal, hit enter. The answer is negative 10.9, right? I need to calculate A of 7, right? This guy actually V prime of 7, right? So I'm gonna print up the calculator again, right? I need to hit menu, calculus right here, derivative right here, variable s, and value should be 7. Alright, I hit OK. I need to input V of s, right? V of s right here, and then I hit enter. Now convert this one to decimal, so hit menu, number, convert to decimal, hit enter. The answer is right here, negative 10.5607, right? Now observe that V of 7 and A of 7 have the same sign, right? Negative, negative. Then the speed of the particles is increasing. Alright, the following table is fairly complete in describing expressions that commonly seen in the particle motion problems. Now, expression on the left hand side and mathematical translation on the right hand side. If you see initial position or velocity or acceleration of the particle, then initial usually means at time t equals 0. We often know initial position, which means s of 0, initial velocity v of 0, or the initial acceleration a of 0 of the particle. Right? Now, particle is at position s equals s1 at time t equals t1. Right? This gives us the position of the particle at a specific time s of t1 equals s1. Right? Now, particle is at rest. Keep that in mind. This means velocity is 0, right? V of t equals 0, right? Now, particle is moving to the right. This means velocity is greater than 0. It tells us that V of t is greater than 0. Particles moving to the left, right? It's going to be opposite to the above. V of t is less than 0. Average velocity of the particles on the interval a, b, right? Remember, you learned this one in 8.1, right? It's going to be 1 over b minus a, integral from a to b of v of t dt, right? But the integral from a to b of v of t dt actually s of t, right? Because you're going to take antiderivative of v of t, you get back to the position function, right? And then you need to evaluate from a to b. Then does that mean s of b minus s of a over b minus a right here, right? Now, instantaneous velocity of the particle at time t equals t1. Then you have v of t1 equals s prime of t1, right? Because the velocity function is the first derivative of the position function. So keep that in mind. Acceleration of the particle at time t equals t1, right? You do exactly the same thing above right here. Take the first derivative of the velocity is the same thing as take the second derivative of the position function, right? So that's why you have s the program of t1. Now velocity of the particle is increasing. This means that the derivative of the velocity is positive. Alright, keep that in mind. This one is different from the speed right here. So be careful, alright? Velocity of the particle is decreasing, which means the first derivative of v of t is less than 0, right? The speed of the particles is the absolute value of the velocity, right? Because the speed always positive. So keep that in mind. The speed of the particle is increasing or speeding up. So it tells us that the velocity and acceleration must have the same sign, right? They both either positive or negative, right? Similarly, the speed of the particle is decreasing or slowing down. Velocity and acceleration must have the opposite sign right here. Right? Now, total distance traveled by the particle over the time interval A to B is to be interval from A to B of absolute value of v of t dt. Right? Remember, total distance, it should be positive. Keep that in mind. Now, displacement of the particle or net distance traveled by the particle over the time interval AB equals the interval from A to B of v of t dt, right? This one doesn't have absolute value sign, right? Because this one is displacement, right? Now, position of the particle at time t equals t2, right? Remember, t1 is the initial value, right? So you have s of t2 equals s of t1 plus the interval from t1 to t2 of v of t dt, right? Because when you take antiderivative of v of t, it's going to be s of t. Keep that in mind. And this one is the initial one, right? This one will be given. Keep that in mind. This one must be the same. Now, the particle changes direction. This occurs where the velocity of the particle changes from positive to negative, from negative to positive, which is, we did it right here, right? Now, the particle is farthest to the left or right, which means you need to find the maximum or the minimum value of s of t over an interval. You need to find the value of t squared. S prime of t1 equals v of t1 equals 0, which means you need to find the critical number, right? Then you need to consider the position of the particle at the critical points, and if the interval is closed, you need to consider the endpoint, right? So basically, for this one, you need to use the candidate test. Now let's move on to example number 2. The space shuttle is an amusement park ride that gently raises riders up a tower and then rapidly passes them up and down using compressed air. The velocity of the space shuttle for t from 0 to 14 is modeled by the piecewise linear function as shown below, where t is measured in seconds and v in feet per second. Question A. At what times in the interval t from 0 to 14, if any, does the space shuttle change direction? Give a reason for your answer. Alright, so we look at the graph right here. This one is the v of t function, right? Now, the space shuttle changes direction when v of t changes signs, right? Now, it changes signs right here, and right here. Why? Because this guy right here above the axis, which means it's positive. This guy right here below the axis is going to be negative. So positive to negative, right? And this one is negative to positive. This one positive to negative, right? So you need to say the spatial changes direction at t equals 6, t equals 8, and t equals 10 seconds, right? Because the sign of v of t changes at this value, right? Let's move on to question B. At what times in the interval 0 to 14 is the spatial the highest, right? So we're going to talk about the precision function, right? So I call precision function is h of t, right? Now, in order to do this one, we need to find the first derivative and we need to find the critical number, right? And we need to use the candidate test, right? Remember? So I have h of t is the high function, right? Now we need to take the first derivative of h of t. It's going to be h prime of t. This guy actually v of t. Makes sense, right? So you need to find a critical point, right? You need to let this one equals 0, right? And we look at the function right here. V of t equals 0 when t equals 6, 8, and 10, right? So we have t equals 6, 8, and 10. Now look at the closed interval right here. We need to include the endpoints, right? So don't forget 0 and 14, right? So we need to use the candidate test, right? So we have the following table. Now h of t is the antiderivative of v of t, right? So it's going to be antiderivative of v of t dt, right? Now remember we start from 0. So the lower bound right here must be 0. The upper bound right here is this number right here, right? Now since the lower bound and upper bound have the same value, this guy must be equals 0, right? Now next one, the interval from 0, right? You always start from 0. This one lower bound. Upper bound should be 6 right here, right? So it could be 6 v of t dt, right? Alright, so we need to take a look at the function v of t where t from 0 to 6, 0 to 6, which is the trapezoid right here, right? So we need to calculate the area of this trapezoid. Base 1 equals 1, 2, 3, 4. It's going to be 4, right? Base 2 is going to be 6, right? From here to here. And the height right here should be 20, right? Remember, look, be careful. Alright, so we have base 1 plus base 2, 4 plus 6 times the height 20 divided by 2, right? So it's going to be red, right? Now, next one we have the interval from 0 to 8 v of t dt, right? Now 0 to 8, which means we need to subtract this guy because this one is below the axis, right? So we need to subtract the area of this triangle, right? So the base is 2, the height is 60, right? So whatever you got right here, 100 right here, you need to subtract base is 2 times height is 60 divided by 2. So it's going to be 100 subtract 60, it's going to be 40, right? Now next one, the interval from 0 to 10 v of t dt, right? So 0 to 10, which means we need to add this guy right here, right? The base is 2, the height is 40, right? So whatever you got 40 right here, you need to add the base is 2, the height is 40, and then you need to divide by 2. So it could be 80, right? And the last one, the interval from 0 to 14, v of t dt, right? So you need to subtract this guy right here, right? So the base is 4, the height is 40, right? So whatever you got right here, 80. Subtract the base is 4, the height is 40, right? Divide by 2. So it should be 0, right? Now, since you need the height is 1, which means the maximum value, right? So the maximum value is right here, 100, right? The space shot is the highest at 100 feet at time t equals 6 seconds, right? Now question C, find the total distance. Remember, total distance must be positive, right? The space shot traveling during the time of the interval 0 to 14, right? So we look at the formula right here. Total distance is going to be right here, right? So it could be integral from a to b of absolute value of v of t dt, right? So it's going to be the integral from 0 to 14 of absolute value of v of t dt, right? Now it's going to be the error of this guy right here, add the error of this guy, add the error of this guy, add the error of this guy, right? Now the error of this guy should be 100. We recalculate it right here, right? The error of this guy equals 2 times 60 divided by 2. It's going to be 60, right? The error of this one equals 2 times 40 divided by 2. It's going to be 40, right? The error of this one equals 4 times 40 divided by 2. It's going to be 80, right? Now you need to add this guy up, so you have 100 at 60 at 40 at 80, right? The answer is 280 feet, right? Remember, be careful, the total distance must be positive, right? Now question D. Write expression for the right acceleration a of t, velocity v of t, and distance s of t from the graph that valid for the time interval 10 to 12, right? The interval from 10 to 12 is going to be this guy right here. So your graph should be this guy right here. Alright, now remember, this one is the velocity function, right? So if you take the first derivative of this one, it's going to be the acceleration, right? But the first derivative of v of t is actually the slope of the function v of t, right? So you need to find the slope of this one, right? So basically, rise over run, right? Now rise right here, you go down by 40, right? And go to the right by 2, right? So this is negative 40 and this is 2, right? So a of t equals rise over run, which means negative 40 divided by 2. It's going to be negative 20, right? Now, v of t, you need to use the point slope from formula. Remember, y minus y1 equals m times s minus s1 to write the function v of t, right? Now the function v of t, the slope is negative 20 right here. Remember the value of the acceleration, actually the slope of the function v of t, right? So we have minus, now I'm going to pick a point. I'm going to pick the point right here, 10, 0, right? Minus 0 equals the slope is negative 20 times t minus 10, right? Now I'm going to simplify this one. So v of t equals negative 20 t plus 200, right? This one is the function of the velocity, right? Now, what about the position function, right? Remember, initial value is 10, right? So we have s of t equals initial value is going to be s of 10 plus the interval from 10 to t, right? Of negative 20 s plus 200 ds. Remember, you need to change the variable right here to s, and then s of t right here depends on the value of t right here, right? So keep that in mind, right? We're going to use the formula right here. It's right here, right? Now let's move on to example number 3. A particle moves in a straight line with velocity v of t meters per second, where t is time in seconds. At time t equals 5, the particle's distance from the starting point was 6 meters. What is the total distance? Right, the keyword right here, total distance. Right, so when it's come to total distance, think about the absolute value sign. Right, the particles has traveled between t equals 5 to t equals 10. Right, the answer absolutely C. Right, the multiple choice 2. A particle moves in a straight line with the velocity v of t equals t squared minus 3t minus 7 meters per second, where t is in times in seconds. At time t equals 2, the particle's distance from the starting point was 10 meters in the positive direction. What is the particle's displacement? Alright, the keyword right here, displacement, between t equals 2 and t equals 9. Alright, so it can be the integral from 2 to 9 of v of t. That's it, right here. Right? Very simple. Now, example number 4. Using the NUT. N stand for now. U stand for units, and T stand for time. Strategy to interpret motion integrals right here. Alright. Now, we have s of 2 plus the integral from 2 to 4 s prime of t dt. Right? At t equals 4 seconds. Right? Now, this one tells us that the position of the particle at t equals 4, right? In fit from the origin. Now, number 2 right here, the integral from 1 to 4 of s prime of t dt, right? So when you take the antiderivative of s prime of t, it tells us that this one is a change in position of the particle, because this one actually s of 4 minus s of 1, right? Now, the units right here should be in feet, right? And the time should be from 1 to 4 seconds, right? If you look at this one, actually the average value, right? Average value of the speed, right? Because absolute value of v of t, right? So you need to say the average speed of the particle. And time should be from 1 to 4, right? This one is similar to the one right here, right? So you need to say the position of the particle at t equals 2 right here. Remember, this guy and this guy must be the same. This one initial position, right? And t equals 2, right? Now look at this one right here. Absolute value of v of t, actually the total distance the particle has traveled, right? And the unit should be feet, right? Now the last one, this one actually the average acceleration of the particle, right? The unit should be feet per second square. Why? Because when you take antiderivative of acceleration, you get the velocity, right? So velocity, the unit should be feet per second, right? And then you divide by times right here, right? Which means you have feet divided by second times second right here. It's going to be feet over second square, right? That's why you get this one, right? Now the time should be from t equals 1 to t equals 4, right? We're going to explore topic 8.3 using accumulation functions and definite intervals in applied context. Alright, let's take a look at example number 1. This one comes from the AP Calculus AP BC pre-response question 2, 2010. A zoo sponsors a one-day contest to name a new baby elephant. Zoo visitors deposited entries in a special box between noon, which means t equals 0, and 8 p.m., which means t equals 8. The number of entries in the box T hours afternoon is modeled by a differentiable function e for t from 0 to 8. Values of e of t's in hundreds of entries at various times t are shown in the table above. Question 8. Use the data in the table to approximate the rate in hundreds of entries per hour at which entries were being deposited at time t equals 6. Alright, so look at the keyword right here. They ask you to approximate that rate at t equals 6. So basically, you need to use the mean value theorem, right? So you have E prime of set equals E of set is between 5 and 7, right? So it could be E of 7 subtract E of 5 over 7 subtract 5, right? E of 7 is going to be 21 subtract 13 over 2, right? So it could be 4. The unit is hundreds of entries per hour, right? Now, question B. Use a trapezoidal sum with the 4 subintervals given by the table to approximate the value of 1 over 8 in row from 0 to 8 of e of t dt. Using correct units, explain the meaning of 1 over 8 in row from 0 to 8 e of t dt in terms of the number of entries. Alright, so we have 4 subintervals, right? So the first one right here, the second one is here, the third one is here, and the fourth one right here. Now this one is the trapezoidal sum, right? So basically the error is going to be base 1 plus base 2 times height divided by 2. Alright, now the height is the width of each interval right here, right? So you have the height is going to be 2, right? The difference between 0 and 2 is going to be 2. Difference between 2 and 5 is going to be 3. Difference between 5 and 7 is going to be 2. And difference between 7 and 8 is going to be 1. So this one is the height. Keep that in mind. Now, base 1 is, for the first interval right here, base 1 is e of 0. Base 2 is e of 2, right? So, you have 1 over 8 interval from 0 to 8 e of t dt. It's going to be 1 over 8 times. Now base 1, which means 0, base 2 for the height is 2, right? So it could be 0 plus 4 divided by 2 times 2, right? Plus next one, base 1 is 4, base 2 is 13, the height is 3, right? So it could be 4 plus 13 divided by 2 times 3, right? Now next one, base 1 is 13, base 2 is 21, and the height is 2, right? So it could be 13 plus 21 divided by 2 times 2, right? And the last one, base 1 is 21, base 2 is 23, and the height is 1, right? So plus 21 plus 23 divided by 2 times height, which means 1, right? Alright, since this one is calculator active, we're gonna bring up the calculator. We're gonna hit add calculator and you just input this expression on the calculator. Alright, so it's gonna be, then you hit enter. The answer is 171 over 16, convert this one to decimal. The answer is 10.687, right? Now, you need to put the units right here. The units of E of T is going to be right here. Hundreds of entries, right? But you calculating the average values, right? Look, 1 over 8, which means 1 over 8 minus 0. The upper bound subtract the lower bound, right? So remember the average value formula is going to be 1 over b minus a, the integral from a to b of f of s ds, right? So you are dividing by times, right? So it should be hundreds of entries per hour. Alright, now you need to explain. So basically you need to say the average number of entries that in the box between noon and 8 p.m. was about 10.68. Alright, let's move on to question C. At 8 p.m., volunteers began to process the entries. They process the entries at a rate modeled by the function p, where p of t equals this one, hundreds of entries per hour, for t from 8 to 12. According to the model, how many entries not yet been processed by midnight t equals 12? Alright, so the key information right here at 8 p.m. Right, so you look at the table right here. At 8 p.m. right here, you already have 2300 of entry, right? So you're gonna start from 23, then you're gonna process, right? Which means you subtract, right? Subtract the integral from 8, right? Right here, to t, right? P, now I'm going to change the variable right here. I'm going to write P of S ds, right? Then it's going to be 23, subtract the integral from a to 12, at t equal 12 right here, of P of S ds, right? So I'm going to bring up the calculator. Now, first I need to store the function P of S right here, right? So I need to hit P of S, control, and the button right here next to number 9, right? And then you're going to input this function right here, right? Right? Now you're going to hit 23, subtract the integral. So basically you hit menu, calculus, integral right here, from 8 to 12. Alright, now you hit enter. The answer is 7, right? So basically it's going to be 700 of entry. Now let's move on to question D. According to the model from part C, at what time were the entries being processed most quickly? It tells us that the maximum value, right? So you're going to use candidate test, right? First, you need to find the critical numbers, right? So basically, you're going to take the derivative of the function p of t, and then you're going to let this one equals 0 to solve for t, right? So I have p prime of t equals 3t squared minus 60t plus 298, right? So I'm going to bring up the calculator. Now I'm going to wrap this one, right? So I'm going to hit on to go to the home screen, hit graph right here, hit enter. It doesn't show up. Now you need to adjust the window, right? So you need to hit menu right here, window setting. Now as minimum right here, I'm going to let this one equal 0, which means the value of t, right? And maximum right here, I can put like 20, right? Now the y minimum right here, negative 10. The y maximum right here should be 10. Now hit enter. It's right here. Alright. Now you need to find the 0 of this function, right? So you hit menu, analyze graph, 0 right here, move to the left, move to the right. the first zero right here. Right, 9.18. Now, second one, menu, analyze graph, 0, move to the left, move to the right. You have the second 0 right here, 10.8, right? So you have p prime of t equals 0, then t equals 9.18, and t equals 10.8. Now you scan the table. Now don't forget to include the endpoint, right? 8 and 12. So 8 go first, 12 the last one right here. You have 2 0 right here, put it over here, 9.18 and 10.8, right? Now you're gonna print up the calculator. Alright, you already saw the function p of t, right? Now you just evaluate the value of p of t when t equals this one right here. Alright, so you have p of 8. Hit enter. The answer is 0, right? P of 9.18. Hit enter. The answer is here. 10.8. Hit enter. The answer is here. And the last one, and P of 12. Hit enter. The answer is right here, right? So I copy it over here. Now you need to pick the maximum value. So the maximum value is right here, right? So you need to say the entries being processed most quickly at t equals 12 hours, right? Let's move on to example number 2. This one comes from the AP Calculus AP BC 2010 free response question 1. There is no snow on Janet driveway when snow begins to fall at midnight. From midnight to 9 a.m., snow accumulates on the driveway at a rate modeled by f of t equal this one, cubic feet per hour. T is measured in hours since midnight. Janet starts removing snow at 6 a.m., which means T equals 6. She's removed snow. The rate G of T is in cubic feet per hour at which Janet removes snow from the driveway at time t hours after the midnight is modeled by this b squared function. Now, question A. How many cubic feet of snow have accumulated on driveway by 6 a.m.? Now look at this one. From midnight to 9 a.m., snow accumulates on the driveway at a rate. Alright, modeled by f of t equal this one. Right, the unit is cubic feet per hour. Now they ask you how many cubic feet only, right? So basically you need to take antiderivative of this one, right? Keep that in mind. So 6 a.m. means t equals 6, right? So you have definite interval from 0 to 6 of f of t dt, right? Now you're gonna print up the calculator. First, you need to store the function f of t, right? So basically, I just hit f of s control and the button right here. It's gonna be 7 times s times e raised to the cosine t, right? Which means cosine s. Hit enter, right? Now you're gonna hit menu, calculus, interval right here from 0 to 6, right? And then this one should be f of s ds, right? Hit enter. The answer is 142.275, right? Cubic feet. Now, you need to read the question carefully. The common mistake students always make is they're gonna calculate f of 6. That's not the case. Be careful, okay? Now, question B. Find the rate of change. The rate of change, which means the first derivative, right? Of the volume of snow on the driveway by 8 a.m., right? The snow accumulates and modeled by the function f of t equal this one. This one is called rate in, right? And Janet start removing snow by the b square function right here, right? So this is called rate out. This one has been taught in 6.4, 6.5, part 2, right? Check out the link in the description below about rate in and rate out, alright? So the rate of change, which means you have f of 8 subtract g of 8, right? F of 8 subtract g of 8, right? 8 is between 7 and 9, so you're going to use 108 right here. Subtract 108, right? Now you're going to bring up the calculator. F of a, the function f is store, right? So you just use f of 8 subtract 108, right? And then it's going to be this guy, convert this one to decimal, right? The answer is negative 59.583. Now question C. Let the function h of t represent the total amount of snow in cubic feet that Janet removed from the driveway at time t hours after midnight. Express the function h as a p-square defined function with domain from 0 to 9. Alright, remember the function h of t is in terms of t, so keep that in mind. Alright, now you're gonna start from 0 first, right? So you have h of 0, right? So look, from 0 to 6, Janet still sleeping, and then she removes nothing, right? It's still 0. So h of 0 equals 0. Now, the first interval 0 to 6 right here, right? So you have 0 less than t less than equal to 6. Then you have the formula that you learned in previous lesson. It's gonna be right here. Alright? H of t equals h of 0, right? Plus the integral from 0 to t g of s ds, right? And it's gonna be h of 0 equals 0, right? So it's gonna be 0 plus, now g of s within this interval is still 0 right here, right? So you have definite interval from 0 to t of 0 ds, right? And then it's gonna be 0. Now the second interval is gonna be 6 to 7. So it's gonna be h of t equals initial value right here 6. So h of 6 plus the integral from 6 to t of g of s ds, right? So h of 6 right here, you look at this one right here, 6 is still in this interval, right? And then it's gonna be 0 right here, so it could be 0 plus, now within this interval 6 to 7, you look at this one right here, 6 to 7 is gonna be 125, right? So from 6 to t of 125 ds, right? So it's gonna be 125 as evaluated from 6 to t, right? So it could be 125 parentheses t minus 6, right? Now, the next interval is going to be from 7 to 9. So 7 less than t less than equal to 9, right? So you have the function h of t equals h of 7 plus the interval from 7 to t g of s ds, right? Now, h of 7 belongs to this interval right here, right? So h of 7 is, substitute 7 for t into this one, is still 125, right? Plus the interval from 7 to t. Now within this interval, it should be 108, right? ds. Now it's gonna be 125, right? Plus 108 as evaluated from 7 to t, right? So it could be 125 plus 108 parentheses t minus 7, right? Finally, you have the answers. Right, let's move on to question D. How many cubic feet of snow are on the driveway at 9 a.m.? I don't have enough space, so I'm going to write over here. Alright, so you have the interval from 0 to 9 of f of t dt. Subtract h of 9, right? This guy tells us that the total amount of snow accumulated over 9 hours. And this guy tells us that the total amount of snow Janice has removed over 9 hours. The interval from 0 to 9 of f of t dt. Subtract h of 9 is, you're going to use this one right here, right? So the function right here, 125 plus 108 times t minus 7. Alright, so you're going to bring up the calculator. Now, you already saw the function FOS, right? So basically, you just hit menu calculus interval from 0 to 9 of f of s ds. Then you subtract t minus 7, but t equals 9 right here, right? So you have 9 minus 7, right? Then you hit enter. The answer is 26.334, right? Cubic feet, that's it. We will explore topic 8.4, error between curves with respect to x. Alright, consider the following graphs: y equals fos and y equals g of s that continues on the interval 1 and 3. Alright, so look at this one, 1 right here and 3 right here. Alright, so this one is the intersection and this one is the intersection, right? So we need to calculate the pin error right here. Alright, so does that mean you're gonna take the error of the region under FOS, right? Which means the green one right here. Subtract the error of the region under the function GOS right here, right? Which is the blue one right here to get the pink one, right? So does that mean the interval from 1 to 3 of the function FOS subtract GOS, right? Equals the interval from 1 to 3 of FOS ds subtract the interval from 1 to 3 of GOS ds, right? In other words, if f and g are continuous on the closed interval a and b, and if g of s less than or equal to f of s, what does it mean? It means that g of s is below the function f of s, right? for all s in the closed interval a and b. Then the area of the regions bounded by the graph f and g, and the vertical lines s equals a and s equals b is given by the formula right here. Alright, where a and b are intersections between two graphs f of s and g of s. Alright, here's the easy way for you to memorize the formula. Alright, then draw from s1 to s2. Take the top curve, subtract the bottom curve. Alright, with respect to s, keep that in mind. Alright, so look at this diagram right here. The function f of s and g of s intersect as this guy and this guy. Right? We need to calculate the area of the shaded regions. Alright, so how do we do that one? I'm gonna call the intersection right here as S1. Right? I call the intersection right here S2. Right? So basically from A to S1, the red one right here, which is the function f of s right here, is above the function g of s, right? So it's going to be the integral from a to s1 of f of s subtract g of s ds, right? Now, from s1 to s2, g of s is above f of s, right? So it could be plus the integral from s1 to s2 g of s subtract f of s ds. Alright, and the last one, the integral from s2 to b. F of s is above g of s, right? So it could be plus the integral from s2 to b. F of s subtract g of s ds. Alright, so keep that in mind. Alright, let's take a look at the first example. Find the area of the regions bounded by the graphs y equals s squared plus 2, y equals negative s equals 0, s equals 1. Sketch the graph and shade the regions. Okay, so basically you need to graph this one first. Alright, so s equals 0, y equals 2. Right, this one is the vertex, right? S equals 1, y equals 3. S equals negative 1, y equals 3. Right, so the graph should look like this. Now, y equals negative s, it's going to be something like this. Alright, now, the lower bound is 0, the upper bound is 1, right? So 0 is right here, upper bound is right here, right? So it's going to be these regions. Alright, so the error should be the integral from 0 to 1. The upper curve, which is y equals s squared plus 2, right? Subtract the lower one is y equals negative s, right? Subtract parenthesis negative s ds, right? So it's going to be integral from 0 to 1, s squared plus s plus 2 ds, right? Now you're going to take antiderivative of this one. It's going to be s cubed times 1/3, right? Plus 1/2 s squared plus 2s, right? Evaluated from 0 to 1. Now substitute the upper bounds right here. It's going to be 1/3 plus 1/2 plus 2. The lower bound is going to be 0, right? So this guy turns out to be 17 over 6. This one is the final answer. Alright, let's take a look at example number 2. Now we need to graph this guy and this guy. Alright, so y equals negative s squared plus 2, right? So s equals 0, y equals 2. It's going to be right here. S equals 1, y equals 1, right? So it could be right here. S equals negative 1, y equals 1, right? So it could be something like this. Alright, so the shaded region should be this guy. Now observe that example number 2 is slightly different from Example number 1. Why? Because you don't have the upper bound and lower bound, right? This one is given upper bound and lower bound right here, right? This one doesn't have it. So how do we do it? We need to find it, right? So we need to find the intersection between two graphs. It's going to be right here and right here. In other words, we need to solve a system of two equations. The first one is y equals 2 minus s squared, right? And the second one is y equals s right here, right? So we just let this guy and this guy equal. So we have 2 minus s squared equals s, right? So we need to solve for s. So it could be s squared plus s minus 2 equals 0, right? We're going to factor this one out. So it could be s minus 1 times s plus 2 equals 0, right? So this one is the zero product. So s minus 1 equals 0. And s plus 2 equals 0, right? Then s equals 1. S equals negative 2, right? So this could be negative 2 right here, and this could be 1 right here. This is exactly right. Alright, so the error should be the interval from negative 2 to 1. The upper function subtract the lower function, right? So upper function is this guy right here. So you have 2 minus s squared. Subtract the lower one is this one, right? ds. Alright, now you're going to take antiderivative of this one. It's going to be 2s minus 1/3 s cubed minus 1/2 s squared, right? Evaluate the form negative 2 to 1. Alright, substitute 1 over here. So we have 2 minus 1/3 minus 1/2. Substitute negative 2 over here. It's going to be negative 4 plus 8 over 3 minus 2. Alright, if you simplify this one, it's going to be 9 over 2. This one is the final answer, right? Now, let's take a look at example number 3. Find the error of one of the regions, right, bounded by the graphs y equals psi s and y equals cosine s. Sketch the graph and shade the regions. Alright, so basically you need to sketch y equals psi s and y equals cosine s, right? Now remember, you learn how to graph these two functions in AP pre-calculus, right? The period of these two functions is 2 pi, right? Now take 2 pi divided by 4. Alright, so it's going to be pi over 2 is 1/4, right? Now you know that the sine function starts from the origin, right? Go up to the maximum in the first quarter. Go back to the midline, right? And go down to the minimum and back up to the midline, right? So it could be something like this. Remember, the sine and cosine function have the same maximum and minimum. It's going to be 1 and negative 1, right? Now, for the cosine function, the cosine function starts from the maximum, right? So it starts from here, right? Go down to the midline, right? Go down to the minimum, back up to the midline, go back to the maximum, right? So it could be something like this. Now you need to find the intersection between two graphs, right? The first intersection right here, and the second intersection is right here, right? And the shaded region should be this one. Now I'm going to show you how to find the intersection points without the calculator, right? So you just equate this guy and this guy, right? So we have sine s equals cosine s, right? Divide both sides by cosine, so it could be sine s divided by cosine s equals 1, right? Remember that cosine must be different from 0, so that when you divide both sides, it's going to be divided, right? And then sine divided by cosine, it could be tangent s equals 1, right? So s equals pi over 4 plus k times pi, right? where k is the integer, right? So first k equals 0, s equals pi over 4, right? Which is right here. And k equals 1, s equals 5 pi over 4, which is right here. The error of this region is the interval from pi over 4 to 5 pi over 4, right? The upper one subtract the lower one, right? Upper one is the sine function. The lower one is the cosine function, right? So it could be sine s subtract cosine s ds, right? Now, you're going to take antiderivative of sine s, it could be negative cosine s, right? And antiderivative of cosine s is going to be sine s, right? So it could be minus sine s. Evaluate from pi over 4 to 5 pi over 4, right? Now, I have negative cosine of 5 pi over 4, subtract sine of 5 pi over 4. Then subtract the lower bound right here, it's going to be negative cosine of pi over 4, subtract sine of pi over 4, right? Alright, now we're going to simplify. Alright, now we're going to use the unit circle. It's right here. This one is pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, and 5 pi over 4 right here. Alright, this one is the cosine axis. This one is the sine axis, right? So cosine 5 pi over 4 equals negative root 2 over 2, right? So, and then you have the negative side right here, so it becomes root 2 over 2, right? Now, sine of 5 pi over 4 is going to be negative root 2 over 2, right? Right here. And combined with negative side right here, it becomes root 2 over 2. Subtract. Cosine of pi over 4 is going to be root 2 over 2, right? So, negative becomes positive, right? Root 2 over 2. Now, sine of pi over 4 is going to be root 2 over 2, right? Negative becomes positive, so it could be root 2 over 2. So we have 4 root 2 over 2. It becomes 4 times root 2 over 2. Alright, so it's going to be 2 root 2 is the final answer. Alright, now you can use the calculator to check your work, right? So you're going to print up the calculator, add graphs right here. First, you're going to hit sine s, right? You hit enter. The answer is right here. Alright, now you're going to graph the cosine function. So you're going to hit tab, put cosine function, check cosine s, hit enter. The answer is right here. Alright, now you need to find the intersection between this guy and this guy right here. Right? So you're going to hit menu, analyze graph, intersection right here. The answer is 0.785, right? Similarly, hit menu, analyze graph, intersection right here. The answer is 3.93, right? And you know that within this interval, the sine function is above cosine function, right? So you're gonna go to the home screen and you hit calculate right here. Hit menu, calculus, the interval right here from 0.785 to 3.93 of sine of s. Subtract cosine of s ds. Hit enter. The answer is 2.828. This guy exactly of 2 times square root of 2. Convert this one to decimal, you will see it, they're both the same. Right? And it's good time to stop. We're going to explore topic 8.5, error between curves with respect to y. Alright, so here's the formula. The error equals the integral form y1 to y2, the right curve subtract the left curve dy. Alright, so basically you need to calculate the error of each horizontal rectangles and you're going to add them up, right? In this situation, it should be with respect to y, right? So the variable should be y, right? Now, example number 1. Find the error of the regions bounded by the graphs s equals 3 minus y squared and s equals y plus 1. Alright, keep in mind the right hand side right here always y, right? The left hand side is s, right? So the first thing you need to do is just get the regions, right? So y equals 0, s equals 3, it's going to be right here, right? Y equals 1, s equals 2, it's going to be right here. Y equals -1, s equals 2, so it could be right here, right? Now the graph should be something like this. Now go ahead, get the second one. S equals y plus 1, y equals 0, s equals 1, it's going to be right here. Y equals 1, s equals 2, it's going to be right here. Now if you connect this one, it should be something like this. Alright, so you need to calculate the error of these shaded regions right here. Now, first you need to find the intersection between two graphs right here. Alright, so you just equate the right hand side, right? Because they both equals s, right? So you have 3 minus y squared equals y plus 1, right? Now convert this one to quadratic equation. So it's going to be y squared plus y minus 2 equals 0. Factor this one is going to be y plus 2 times y minus 1 equals 0. Alright, this one is the 0 product, so it should be y plus 2 equals 0 and y minus 1 equals 0, right? So this guy turns out to be y equals -2, y equals 1, right? So the error becomes the integral form -2 to 1, right? This one right here, y equals -2, and this one right here, y equals 1, right? Now, right curve subtract left curve, right curve, which means the right one right here. So it could be 3 minus y squared subtract y plus 1, right? And then this one should be dy, right? So this guy turns out to be the integral form -2 to 1. Simplify this one, it's going to be negative y squared minus y, right? Distribute -1 right here plus 2 dy, right? Now take antiderivative of this one, so it's going to be -1/3 y cubed minus 1/2 y squared plus 2y, evaluated from -2 to 1. Alright, substitute 1 over here, so it's going to be -1/3 minus 1/2 plus 2. Substitute -2 over here, it's going to be y cubed, it's going to be -8 times -1 right here, it's going to be positive, right? So it should be 8 over 3. -2 squared, it could be 4, so it could be subtract 2 and minus 4, right? Because -2 times 2. Now, if you simplify this one, the answer must be 9/2. Alright. Now let's take a look at example number 2. Find the error bounded by the curves x equals y squared minus 2. Y equals -1, y equals 1, and x equals e to the y. Alright, so this one is e to the y, and this one is y squared minus 2, right? Now we need to shade the regions that is bounded by those given equations. Alright, so it should be this guy right here, right? Because you have y equals -1 right here, and y equals 1 is going to be right here, right? So the error is the interval from -1 to 1, right? Look, from here to here. Right, subtract left, right? Right is this one right here. So it could be e to the y subtract left, which is this one right here. Y squared minus 2 dy. Be careful, you need to put the parentheses right here. So it's going to be the interval from -1 to 1, e to the y. Distribute -1 is going to be -y squared plus 2 dy, right? Now take antiderivative of this one with respect to y. So it could be e to the y minus 1/3 y cubed plus 2y, right? Evaluated from -1 to 1. Alright, substitute 1 is going to be e minus 1/3 plus 2, right? Substitute -1 for y, so it could be e to the -1 minus 1/3 times -1 cubed, right? Plus 2 times -1. Now we're going to simplify this one. It's going to be e 5/3, right? Now this one right here is going to be 1/e. So you distribute -1, it's going to be -1/e. This guy right here becomes 1/3, right? And distribute -1 is going to be -1/3. This guy becomes -2. Distribute -1 is going to be plus 2, right? So it's going to be e minus 1/e, right? Now 5/3 subtract 1/3 is going to be 4/3, right? 4/3 plus 2 is going to be 10/3, right? This one is the final answer, right? Now, example number 3. Redo example number 1 with respect to s, which means we're going to use the vertical representative rectangles, right? We look at the example number 1 right here. S equals 3 minus y squared. Alright, so s equals 3 minus y squared. You need to write y in terms of s, right? So it's going to be y squared equals -s plus 3, right? Then you're going to take square root both sides, right? So it's going to be y equals plus and minus square root of 3 minus s, right? Now, the second equation is going to be s equals y plus 1. Then you need to rewrite y in terms of s. So y equals s minus 1, right? You just let this guy and this guy equals, so that you're gonna find the intersection, right? Which is I did in the first example, right? So I have y equals -2 and y equals 1, right? So y equals -2, you just substitute -2 for y into this equation right here to solve for s. So s equals -1, right? Similarly, y equals 1, s equals 2, right? That's why you have 2 points right here, right? Now, the error is now from left to right. It's going to be from -1 2, 2. You see that the linear function right here is above this guy right here. This guy right here is y equals negative square root of 3 minus s, right? So it's going to be the integral from negative 1 to 2 of the upper one, which is this guy right here, s minus 1, subtract the lower one right here, which is this guy, negative, so it turns out to be plus, right? 3 minus s ds. Now plus the integral from 2 to 3 right here. How do we know this one 3? We need to find the intersection between this guy and the x-axis. The x-axis, which means y equals 0, right? So basically, you just equate this guy and this guy, right? The system of equation y equals square root of 3 minus s and y equals 0. Then I just equate this guy and this guy. So I have square root of 3 minus s equals 0. Square both sides. 3 minus s equals 0. S equals 3, right? That's why I have 3 right here. So it's going to be the integral from 2 to 3, right? Remember this guy right here. Alright, now the integral from 2 to 3, and you observe that this guy and this guy symmetric, right? Only calculate the error of upper half right here and you multiply by 2, right? In order to calculate the error of upper half right here, does that mean you're going to take the upper function, subtract the lower function? The upper function is this guy. The lower function is y equals 0, which is the x-axis, right? So I have square root of 3 minus s, subtract 0, I don't need to write it, right? ds. Then I'm going to multiply by 2, so I'm going to put 2 in the front, right? I'm going to separate this one into 2 integrals, right? So it's going to be the integral from negative 1 to 2 of s minus 1 ds plus the integral from negative 1 to 2 square root of 3 minus s ds, right? And this guy right here plus 2 times the integral from 2 to 3 of square root of 3 minus s ds, right? Now, it's very simple to calculate the integral of this one, right? Now, for this guy right here, I'm going to use substitution, right? So, I'm going to call this one I1, I call this one I2, I call this one I3. I need to calculate each of this one, and I'm going to add them up, right? Alright, now I'm going to calculate I1. So, I1 is the integral from negative 1 to 2 of s minus 1 ds. Alright, take antiderivative of this one is going to be s squared over 2 minus s, evaluated from negative 1 to 2, right? And this guy turns out to be, substitute 2 for s, so it's going to be 2 minus 2, right? And substitute negative 1 for s is going to be subtract 1/2 plus 1, right? So it's going to be negative 3/2. Alright, now I2, you're going to use substitution. So basically, you're going to let u equals the square root side right here. 3 minus s, right? Then you're going to square both sides. So you have u squared equals 3 minus s, right? Then you're going to take the derivative both sides. So it could be 2u du equals negative ds, right? Now I'm going to multiply both sides by negative 1. So I have negative 2u du equals ds, right? Now I need to change the bounds. Upper bounds is s equals 2, lower bound s equals negative 1. Then u becomes, substitute 2 for s into this guy right here. So you have u equals 1. Substitute negative 1 for s, u equals 2, right? Now I2 becomes the integral form 2 to 1, right? This guy right here actually u. ds right here actually this guy right here, right? So I have negative 2u squared du, right? Now I need to flip about and I'm going to change the sign right here so it becomes positive, right? Integral from 1 to 2 u squared du, right? Now take antiderivative of this one, so it could be 2 over 3 u cubed evaluated from 1 to 2. So it could be 2 over 3 times 2 cubed minus 1 cubed, right? So it could be 8 subtract 1 is going to be 7. 7 times 2 is going to be 14 over 3, right? Now I3 I do exactly the same thing, right? The only thing different right here is the bounds, right? The lower bound s equals 2, the upper bound s equals 3, right? Right here. Then u becomes, substitute 2 for s into this one right here. U becomes 1, right? Substitute 3 for s, u becomes 0, right? So I3 becomes the integral form 1 to 0 negative 2u squared du, right? So you need to flip the upper bound and lower bound and change the sign. So it's going to be the integral from 0 to 1 of 2u squared du. And then it's going to be 2 over 3u cubed evaluated from 0 to 1. Right, so it could be 2 over 3 times 1 minus 0. It's going to be 2 over 3. Now, for I3, you need to be careful. You must multiply by 2 right here. Right? So this guy becomes 4 over 3, right? So you have the error equals I1 equals negative 3 over 2. I2 equals 14 over 3. And I3 equals 4 over 3, right? So it could be negative 3 over 2 plus 18 over 3, right? Now cross multiply, so it could be negative 9 plus 36 over 6, right? So it could be 27 over 6. Divide the top and bottom by 3. So it could be 9 over 2. This one is the final answer. So this one matches the first example right here. Alright. Now let's move on to example number 4. Vertical and horizontal representative rectangles. Find the area of the regions enclosed by the curves y equals 1 over s. Right, the red one right here is y equals 1 over s. Right, y equals s is this one right here. And y equals 1 for s is complete right here. Alright, so the first thing you need to do is to find the intersection points, right? So in order to find this intersection right here, I need to equate this guy right here and this guy right here, right? So I have y equals 1 over s and y equals s, right? I just equate this guy. So this guy turns out to be s equals 1 over s, right? And then multiply both sides by s. So it's going to be s squared equals 1. Then s equals plus and minus 1. And you look at this graph right here, you only need s equals 1, right? It's going to be on the right of the y-axis, right? And then substitute over here. So y equals 1, right? So you have the first order pair, it's going to be 1 and 1. It's going to be right here. Now, secondly, you're going to find the intersection right here, which is between this guy and this guy, right? So you have y equals 1 over 4 times s and y equals 1 over s, right? So it could be 1 over 4 times s equals 1 over s, right? Now cross multiply, so it's going to be s squared equals 4. Then s equals plus and minus 2, right? So we only take s equals 2 because it's on the right of the y-axis, right? Then substitute 2 for s into this guy right here. So y equals 1/2, right? That's why you have the point 2, comma 1/2 is right here, right? Now question A. We need to calculate the error of this guy with respect to s right here, right? So we're gonna go from left to right, right? Left right here, right here. So we're gonna split this one into two error. The first one is A1 right here. The second one is A2 right here, right? For A1, the upper one should be y equals s. The lower one should be y equals 1 over 4s, right? For A2 right here, the upper one should be the red one right here, y equals 1 over s. The lower one should be y equals 1 over 4s, right? So you have the integral from s equals 0 and s equals 1 right here. 0 to 1. Upper subtract lower. The upper one is y equals s. The lower one is this guy, right? Plus the integral from 1 to 2, right? Right here. The upper one is 1 over s. The lower one is 1 for s, right? Alright, now take antiderivative of each of this one. So it's going to be 1/2 s squared minus 1 over 8 s squared, right? Evaluated from 0 to 1 plus antiderivative of 1 over s could be natural log of absolute value of s minus 1 over 8 s squared evaluated from 1 to 2, right? So you're going to simplify this one. It becomes, substitute 1 for s, it could be 1 over 2 minus 1 over 8. Substitute 0 for s, it could be 0, right? So I don't need to write. Plus substitute 2 for s, it could be natural log of absolute value of 2 minus substitute 2 for s over here and simplify it could be minus 1/2, right? Substitute 1 for s, it could be natural log of 1. Substitute 1 for s, it could be negative 1 over 8, right? Now I'm going to simplify this one. It could be 1 over 2 minus 1 over 8 plus natural log of 2. I don't need the absolute value side because this one is positive, right? Minus 1 over 2. Natural log of 1 equals 0, right? And this guy, distribute negative 1 over here, it's going to be 1 over 8, right? This guy cancel out. This guy cancel out. The answer is natural log of 2, right? Now for question B, we're going to use y as the variable of integration, right? So we need to go from bottom to top, right? Now the first intersection is right here. The second intersection is right here. And the third one right here, right? So I'm going to project this one to the y-axis, right? So the y values right here should be 1/2, right? And the y values right here should be 1, right? So I have the integral from 0 to 1/2, right? Now right subtract left, right? So the right one right here and the left one is right here, right? The error of this region right here. Alright, now I need to rewrite this one in terms of y, right? So I'm going to multiply both sides by 4. So s equals 4y, right? So I have 4y right here. Subtract y, right? dy plus the integral from 1/2 to 1, right? Now the regions is this guy right here, right? So right subtract left, right is right here, and left is right here, right? We write this one in terms of y, right? So s equals 1 over y, right? So I have 1 over y subtract y dy, right? Alright, now I'm going to check antiderivative of this guy. So antiderivative of 4y is going to be 4 over 2 y squared is going to be 2y squared. And this guy becomes negative 1 over 2 y squared, right? Evaluated from 0 to 1 half plus antiderivative of 1 over y is going to be natural of absolute value of y minus 1 over 2 y squared. Evaluated from 1 half to 1, right? Alright, so I'm going to simplify this one. Substitute 1 half over here is going to be 1 over 4, right? So simplify 2 is going to be 1 half. 1 half substitute over here is going to be 1 over 4, and 1 over 2 is going to be negative 1 over 8. Substitute 0, everything is 0, right? Now for the second one right here, substitute 1 over here. You have natural log of 1. Substitute 1 over here is going to be negative 1 over 2. Substitute 1 half is going to be natural log of absolute value of 1 over 2. Substitute 1 half for y is going to be 1 over 4. And then it's going to be negative 1 over 8. Right? Now I'm going to distribute, so it's going to be 1 over 2 minus 1 over 8. Natural log of 1 equals 0, right? So it's going to be negative 1 over 2. Minus natural log of 1 over 2 plus 1 over 8, right? This guy cancel out, this guy cancel out. It's going to be negative natural log of 1 over 2. Alright, so it's going to be negative of natural log of 1 subtract natural log of 2, right? So it's going to be negative natural log of 1 plus natural log of 2. Natural log of 1 equals 0, so the final answer should be natural log of 2, which is exactly same thing as question 8 right here, right? We're going to explore topic 8.6a, error between curves more than 2 intersections. Alright, example number 1. The curves that intersect at more than 2 points. Find the error of the regions between the graphs. LS equals 3s cubed minus s squared minus 10s. And g of s equals negative s squared plus 2s. Alright, so we're gonna graph this one. This one actually cubic function. So which is the blue one right here, f of s. And g of s is the quadratic function with the red one right here, g of s. Alright, now you need to find the intersection between these two graphs, right? So basically, you just let f of s equals g of s, which is 3s cubed minus s squared minus 10s equals negative s squared plus 2s to find the intersection points, right? And then both sides have the same negative s squared, you're going to cancel out, right? So you have 3s cubed, subtract 2s both sides, so it could be negative 12s equals 0. Factor 3s out, so you have 3s times s squared minus 4 equals 0. Then you have 3s equals 0 and s squared minus 4 equals 0, right? This guy turns out to be s equals 0 and s equals plus and minus 2, right? So you have 3 intersections right here. The first one right here, s equals negative 2, right? The second one right here, s equals 0, and the third one right here, s equals 2, right? So you're going to split these regions into 2 regions, right? The first one is A1 right here. The second one is A2, right? So the error equals A1 plus A2, right? Now A1, which is the integral from negative 2 to 0, right? Of the blue one, subtract the red one, right? The upper one subtract the lower one, because this one is the integral with respect to s, keep that in mind. So it's gonna be FOS subtract 3 of s is gonna be 3s cubed minus s squared minus 10s, right? Subtract negative s squared plus 2s ds, right? Now, plus a2. a2 is the integral from 0 to 2, which is this guy right here. The upper one is g of s, which is negative s squared plus 2s. Subtract FOS is going to be 3s cubed minus s squared minus 10s, right? ds. Now, you're going to distribute the negative side, so this guy turns out to be integral from negative 2 to 0, right? Negative right here becomes positive, right? So you have positive s squared, and you have negative s squared right here is to be cancelled out, right? Now, negative times 2s is to be negative 2s, and you have negative 10s right here is to be negative 12s, right? You will write 3s cubed ds. Now you simplify the second one and the integral from 0 to 2. Negative 3s cubed, right? Negative and negative right here becomes positive, and this guy right here cancel out, right? Now negative and negative right here becomes positive, so positive 10s and 2s is going to be positive 12s ds, right? Alright, now I'm going to take antiderivative of this one is going to be 3 over 4s power 4, right? Minus 12s squared over 2 is going to be 6s squared. Evaluated from negative 2 to 0, right? Now take antiderivative of this one is going to be negative 3 over 4s to the 4, right? Plus 6s squared evaluated from 0 to 2, right? Now you're going to substitute 0 for s, it's going to be 0, right? Subtract parenthesis 3 over 4 negative 2 power 4 is going to be 16, right? Times 16. Subtract 6 times negative 2 square, right? Plus negative 3 over 4 times 16, right? Substitute 2 over here is going to be plus 24. 16 divided by 4 is going to be 4. 4 times 3 is going to be 12, right? So it's going to be negative 12 right here. And this one right here, negative 2 squared could be 4, right? 4 times 6 it could be 24. So you have negative side right here. It's going to be negative 24. So you multiply by negative 1 right here, it's going to be plus 24, right? Similarly, this one turns out to be negative 12 and then plus 24, right? And if you simplify this one, it's going to be 24. This one is the final answer. You can use the calculator to check your work, right? Now let's move on to example number 2. The figure below shows the graph of y equals 2 minus 1 half s squared and the line y equals 1. For s from negative 2 to 2. Set up the integrals for the sum of the errors of the shaded regions, right? So very simple, right? You have 3 shaded regions right here. The first one is here, right? The second one is this guy. And the third one is this guy, right? So the question just asks you to set up, so basically you just set up, you don't need to calculate, right? So the error becomes, now you need to find the intersection right here first, right? You know that the first intersection is here, right? So you're gonna let this guy right here equals this guy, right? To solve for s, right? So you have 2 minus 1 half s squared equals 1, right? Multiply both sides by 2 right here. So then you have 4 minus s squared equals 2, right? So I have s squared equals to s equals plus and minus root 2, right? So this one right here actually negative root 2, right? And this one right here actually root 2, right? And this one right here is negative 2, this one is 2, right? So the error becomes the integral from negative 2 to negative root 2 of, look at this one right here, the upper one subtract lower one, the upper one is y equals 1, right? This is y equals 1. The lower one is the function right here, right? So you have 1 minus parenthesis 2 minus 1 half s squared ds, right? Be careful. You must have the parenthesis of this one, right? Plus the integral from negative root 2 to root 2, right? Of the upper one subtract the lower one, right? Upper one is 2 minus 1 half s squared. Subtract lower one, which is 1, right? So right here you don't need to put parentheses, right? Because you only subtract 1, right? Right here you subtract a polynomial, right? And you put the s right here. And the last one plus the integral from root 2 to 2 right here, right? Of the upper one is y equals 1. Subtract lower 1, put parentheses right here. 2 minus 1 half s squared ds, right? And this guy is the final answer. Now let's move on to example number 3. Let R be the regions bounded by the graph y equals e to the 3s minus s squared, the horizontal line y equals 1, and the y equals 3. As shown in the figure below, find the area of these bounded regions, alright? So y equals 3 right here. And this one y equals 1. And this one is y equals e raised to the 3s minus s squared, right? This graph right here has 4 intersections. The first one is right here. The second one is right here. The third one is here. And the last one is here. Alright? So you need to separate them. Alright? You need to find the intersection right here. You know that intersection right here and right here already 3 and 0. Right? Anyway, you need to calculate it. Right? So I need to find the intersection right here. And right here, right here. So does that mean I need to solve a system of equations, this guy and this guy right here, right? So I put this guy right here on the calculator, and I need to find the intersection because this one is the calculator active, right? Or if you want to solve this one by hand, that's fine, totally fine, right? Because you have e raised to the 3s minus s squared equals 1, which is e raised to the power of 0, right? So then you just equate this guy right here and this guy right here. So I have 3s minus s squared equals 0. Factor s out, so I have s times 3 minus s equals 0. So I have s equals 0 and s equals 3, which is right here and right here, right? Now, for the second one right here, I need to solve a system of equation, this guy right here and this guy right here. I need to use a calculator because I have the decimal number right here, right? So I'm going to bring up the calculator, right? I'm going to grab this guy and this guy on the calculator and I'm going to find the intersection, right? So I need to go to home screen, hit on right here, grab right here. Alright, f1 of s is going to be e raised to the 3s minus s squared, right? Hit enter, it's gonna be right here. Alright, the second one is y equals 3, so I need to hit tab, so I put 3, hit enter, it's gonna be right here. Now I need to find the intersection right here, so I need to hit menu, analyze graph, intersection, go to the left, go to the right, it's gonna be 0.427, right? 0.427. Now the second one is hit menu, analyze graph, intersection, go to the left, go to the right. It's going to be 2.57. So you have three bounded regions. The first one is right here. This one and this one should be the same. The middle one is right here, actually the rectangle, right? So you have error is, now I call this one A1, I call this one A2, I call this guy is A3, right? So does that mean A1 and A3 they're both the same, right? So can I combine them as 2A1, right? Plus A2. Now 2A1, which means the interval from 0 right here to 0.427, right? Upper one subtract the lower one. The upper one is the function right here, right? Because it's going to be right here. The lower one is y equals 1, right? So you have e raised to the 3s minus s squared minus 1 ds, right? Plus the middle one right here from 0.427 to 2.57. The upper one is y equals 3. The lower one is y equals 1. So 3 subtract 1 is going to be 2 ds, right? Now I'm going to put this guy on the calculator. I need to hit home screen right here, hit calculate. Now I need to hit menu, calculus, integral, right? I need to put 2 in the front right here, right? Integral from 0 to 0.427 of e raised to the 3s minus s squared minus 1, right? ds plus menu, calculus, integral from 0.427 to 2.57 of 2 ds. Hit enter. The answer is 5.03391, right? So this one equals 5.03391. Now let's move on to example number 4. Find the error of the regions bounded by the curve y equals sine s, cosine s, s equals 0, s equals pi over 2, right? Now you need to grab this guy and this guy, right? So I have s and y coordinates right here. Now observe that the sine and the cosine function have the same periods. It could be 2 pi, right? And then you need to find the length of 1/4, right? So you're going to take this one divided by 4. So I have 2 pi divided by 4 is going to be pi over 2, right? So from here to here I have the period is 2 pi. Divide 2 pi in half is going to be pi. Divide this one in half is going to be pi over 2. Divide this one in half is going to be 3 pi over 4, right? So you have 4 quarters. Each quarter has the length of pi over 2, right? Now, this one is the maximum is going to be 1, minimum is -1, right? You know that the sine function starts from the origin, right? And it's going to be right here, right? Go up to the maximum on the first quarter. The second quarter go down to the midline. The third quarter is the minimum. It's going to be right here, right? And the last quarter is going to be right here. So it's going to be something like this. Alright, now the cosine function starts from the maximum, so it could be right here. Go down to the midline. Go down to the minimum right here. Back up to the midline. Go up to the maximum. Alright, so it could be something like this. Now x equals 0 is going to be the y-axis, right? So it could be right here. Now x equals pi over 2 is going to be right here, right? So you have two regions. The first one is right here, and the second one is right here. So which is right here. You see that A1 and A2 right here. Alright. And you need to find the intersection right here, right? In order to find the intersection, you need to let sine s equals cosine s, right? This guy right here equal this one, right? Because they both equals y, right? So divide both sides by cosine, so it can be sine s divided by cosine s equals 1, right? Assume that cosine always not equal to 0, right? Because if cosine equals 0, it's going to be undefined, right? So it could be tangent s equals 1, right? So you have s equals pi over 4 plus n pi, right? Where n is an integer, right? Now if n equals 0, you get pi over 4, right? So which is right here, pi over 4, right? Now the error becomes the integral form 0 to pi over 4. The upper one subtract lower one. The upper one is the cosine function. The lower one is the sine function, right? Look, the orange one is above the blue one, right? So you have cosine s subtract sine s. Now, plus the integral form pi over 4 right here. 2 pi over 2, right? Look at the intersection right here. Now the upper one is the blue one, which is sine s subtract cosine s ds, right? Now you're gonna simplify this one by taking the antiderivative of this one, right? So antiderivative of cosine is gonna be sine s. Antiderivative of sine is gonna be negative cosine, and you have negative side of it, it becomes positive cosine, right? Evaluate from 0 to pi over 4 plus the antiderivative of sine s could be negative cosine s. Antiderivative of cosine s could be sine s, right? So it could be negative sine s right here. Evaluate from pi over 4 to pi over 2, right? Now substitute pi over 4 for s, so sine pi over 4 equals root 2 over 2. Cosine pi over 4 is going to be root 2 over 2. Now substitute 0 for s, it's going to be sine of 0 is going to be 0, cosine of 0 is going to be 1, right? Now this one right here plus negative cosine pi over 2 equals 0, right? Sine pi over 2 equals 1, right? Minus 1. Subtract pi over 4. Cosine pi over 4 equals root 2 over 2, so it could be negative root 2 over 2. Sine pi over 4 equals root 2 over 2, so it could be negative root 2 over 2, right? Root 2 over 2 plus root 2 over 2, it could be root 2, right? This one is negative 1. This one is negative 1, so it could be minus 2, right? Now, this should be negative 1, it could be plus root 2, right? So it could be 2 root 2 minus 2. This one is the final answer. Now, there is a faster way to do this one. Observe that this region right here and this region right here symmetric about s equals pi over 4, right? Look. Alright, and they're both the same, right? So basically, you just calculate the error of one region right here and you multiply by 2, right? So basically, I just put 2 right here and I don't need this one. So it saved my time, right? You still get the same answer, right? The answer for this one right here is root 2 minus 1. Then you're going to multiply by 2, you get this one right here. Let's learn how to prove two symmetric intervals. The first one, if the function f is even, then the integral from negative a to a of f of s ds equals 2 times the integral from 0 to a of f of s ds. The second one, if f of s is odd, then the integral from negative a to a of f of s ds equals 0, right? So I have the integral from negative a to a of f of s ds equals the integral from negative a to 0 f of s ds plus the integral from 0 to a of f of s ds, right? I just split it into two integrals, right? Now for the first one right here, I just let u be negative s, right? Then negative u equals s, right? So you take the derivative both sides, so it will be negative du equals ds, right? Now go ahead change the lower limit and upper limit, right? S equals negative a, s equals 0. Then u becomes a and u becomes 0, right? So from negative a to 0 of f of s ds equals the integral from a to 0 of f of negative u times negative du. Now I will bring this negative side outside, right? Now I need to flip the upper bound and lower bound right here. So this guy becomes positive, right? So it could be the integral from 0 to a of f of negative u du, right? Since the function f of s is even, right? So you have f of negative u becomes f of u, right? If you want to learn more about even and odd functions, please check out the link in the description below. So this guy becomes the integral from 0 to a of f of u du, right? Now since this variable right here and this variable right here agree, right? So you can rewrite this one as integral from 0 to a of f of s ds, right? I need to replace this guy right here with this guy, right? So it turns out to be 2 times the integral from 0 to a of f of s ds, right? So the first one has been proved, right? Now for the second one, I'm going to do exactly the same thing. So I'm going to split this one into two integrals. Now I'm going to do u substitution, right? So I let u be negative s, right? So then s equals negative u, right? So I'm going to take the derivative both sides. ds equals negative du, right? Now I need to change the upper bound and lower bound, right? S equals negative a and s equals 0. Then u becomes a and u becomes 0, right? So this integral right here becomes integral from a to 0 of f of negative u du, and I put the negative side in the front, right? Now since the function f is odd, right? So if the function f is odd, f of negative s equals negative f of s, right? So this guy becomes negative of integral from a to 0. Then this guy becomes negative f of u du, right? Now these two negative sides become positive, right? So I just remove two negative sides, right? Now since this variable agrees with this variable, right? So I just rewrite this one as the integral from a f of s ds, right? Now I need to put this guy back over here, right? So this guy turns out to be the integral from a to 0 of f of s ds plus the integral from 0 to a of f of s ds, right? Now I need to flip the limits, right? So this one and this one becomes 0 to a, and then I need to put the negative side right here, right? So this guy actually 0, right? So this one has been proved, right? Now, if you have another way to prove this one, please leave a comment. We're going to explore topic 8.6c, error between curves with even and odd functions. We have two formulas. The first one, if the function f is even, then the integral from negative a to a of the function f of s ds equals 2 times the integral from 0 to a f of s ds, right? It tells us that the function f of s is symmetric about the y-axis, right? Now, if the function f is odd, then the integral from negative a to a of the function f of s ds equals 0, right? Because the function f of s is symmetric about the origin, right? And remember that if the function f is even, you have f of negative s equals f of s, right? If the function f of s is odd, you have f of negative s is negative f of s. Alright, so keep that in mind. Now, check out the link in the description below for the proof of the two formulas right here. Let's take a look at the first example, even functions. Find the error of the regions bounded by the graph of the y equals 4 minus s squared and the x-axis. So does that mean your error should be this guy? The error should be the integral from the left end bound is negative 2, the right end bound is 2, right? Negative 2 to 2 of f of s. Upper function subtract the lower function. The lower function is y equals 0 right here, right? So you subtract 0 ds, right? And this guy turns out to be the integral from negative 2 to 2 of f of s ds, right? But f of s is 4 minus s squared right here, so it's going to be integral from negative 2 to 2 of 4 minus s squared ds. Alright, now I'm going to check to see if the function f of s is even or odd, right? So I have f of s equals 4 minus s squared, right? Then f of negative s equals 4 minus parentheses negative s altogether squared, right? So it could be 4 minus s squared, and it's actually f of s, right? So I just proved that f of negative s equals f of s. It tells us that f of s is even, right? So if f of s is even, this guy right here becomes 2 times the integral from 0 to 2 of 4 minus s squared ds, right? I'm going to use the formula right here. Alright, so this guy turns out to be 2 times antiderivative of 4 is going to be 4s minus s cubed over 3 evaluated from 0 to 2, right? So I'm going to simplify this one. It's going to be 2 times, substitute 2 for s, so it could be 8 minus 8 over 3. Substitute 0 for s, it could be 0, right? So this guy turns out to be 2 times 16 over 3, right? So it could be 32 over 3, right? This one is the final answer. You can use the calculator to check your work, right? You hit add calculator right here. Hit menu, calculus, integral from 0 to 2 of 4 minus s squared ds, right? And don't forget to multiply by 2, right? Hit enter. The answer 32 over 3, right? Now let's take a look at the example number 2, even trig functions. Find the error of the regions bounded by the graph y equals 1/2 cosine s, the x-axis, and the line s equals plus and minus pi over 2, right? So minus pi over 2 should be this guy, plus pi over 2 should be this guy, right? So does that mean the error of these regions right here? Right? Now, observe that these regions right here symmetric about the y-axis, right? Half of this one right here and half of this one right here. Now we're going to check to see if this function is even or odd algebraically, right? So we have f of s equals 1/2 cosine s, right? Then you have f of negative s is going to be 1/2 of cosine of negative s, right? But cosine of negative s actually cosine of s, so it will be 1/2 cosine of s, and this guy actually f of s, right? So you just prove that f of negative s equals f of s. It tells us that f of s is even, right? So the error of this guy should be the integral from negative pi over 2 to pi over 2 of 1/2 cosine of s ds, right? Alright, so this guy turns out to be 2 times the integral from 0 to pi over 2 1/2 cosine s ds, right? And then 2 and 2 right here cancel out, so it could be integral from 0 to pi over 2 of cosine s ds, right? And time derivative of cosine s could be sine s, right? So it could be sine s evaluated from 0 to pi over 2, right? So I substitute pi over 2 for s, so it could be sine of pi over 2 minus sine of 0, right? Sine of pi over 2 equals 1. Sine of 0 equals 0. The answer is 1. This one is the final answer. Now we can use the calculator to check our work, right? So we're going to bring up the calculator. Hit menu, calculus, integral from negative pi over 2. So I'm going to hit fraction right here, right? So I hit pi over 2. Don't forget negative side right here, right? And you copy this one, I'm going to put over here. Of 1/2, which means 0.5, right? So I have 0.5 cosine s, right? Hit cosine s ds and hit enter. The answer is 1, right? Now let's move on to example number 3, odd functions. Find the error of the regions bounded by the graph y equals 1/8 s cubed plus 1/2 s, the x-axis, and the line s equals plus and minus 2, right? So minus 2 is going to be right here. Plus 2 is going to be right here. Alright, so does that mean the region should be this guy right here and this guy right here? Alright, now we're going to check this one to see if it's even off, right? So I have f of s equals 1/8 s cubed plus 1/2 s, right? Then I have f of negative s. It's going to be 1/8 times negative s cubed plus 1/2 times negative s, right? Then this guy turns out to be negative 1/8 s cubed minus 1/2 s, right? I factor negative 1 out, so it could be negative parenthesis 1/8 s cubed plus 1/2 s, right? Now look at the one inside parenthesis. This guy actually f of s, right? So I will write negative side right here, and I put f of s right here. Now I just prove that f of negative s equals negative f of s, right? So this guy tells us that the function is right? So the integral from negative 2 to 2 right here of this guy right here is 0. This one is the final answer. Now you can use the calculator to check it work, right? So you hit menu, calculus, integral from negative 2 to 2, right? Right here, 1/8 times s cubed plus 1/2 times s ds. Hit enter. The answer is 0, right? Now let's move on to example number 4. Find the error of the regions bounded by the graph y equals 1/2 sine s, the x-axis, and the line s equals plus and minus pi, right? Minus pi is right here. Plus pi is right here, right? And the error should be this region right here, right? And observe that this guy symmetric about the origin, and this guy actually the odd function. The error must be 0, right? Now we're going to check this one algebraically, right? So we have f of s equals 1/2 sine s, right? Now we have f of negative s equals 1/2 times sine of negative s, right? But sine of negative s equals negative sine s, so it will be negative 1/2 sine s, right? I put this one inside parentheses. So I will write negative sine right here. This guy right here, actually, this guy right here. So it will be negative f of s, right? Now I just proved that f of negative s equals negative f of s. So this guy tells us that the function f of s is odd, right? So the error is the integral from negative pi to pi of 1/2 sine s ds. This guy actually 0, right? Now you can check your work with calculator, right? So you're gonna hit menu, calculus, integral from negative pi to pi of 1/2 times sine s ds, hit enter. The answer is 0, right? We're going to explore topic 8.7 and 8.8. Find the volume of the solids using the cross sections, squares, rectangles, triangles, and semicircles. Alright. You look at the figure right here. Alright, this one is the 3D figure. Kaufman Center for the Performing Arts in Kansas City. Alright, and you observe that the cross section right here is the semicircle. They are repeating and getting bigger and bigger, right? The AP calculus exam will focus on 4 familiar shapes from geometry: the square, the rectangle, the semicircle, and several variety of triangles. Right? Now, if you have the square, in order to calculate the error of the square, does that mean you need a side length, right? So the error is side square, right? The rectangle, you need the length and the width, and the error is going to be length times width, right? The semicircle, you need the radius, right? Then the error is pi times r squared. Now the triangle, you need base and height, right? Then the error is 1/2 base times height, right? Now equilateral triangle, you learn in geometry. Now suppose the equilateral triangle has the side A, right? So this guy is A, this guy is A, and this guy is A, right? In order to calculate the error of the equilateral triangles, you need to draw the altitude, right? So the error is 1/2 base times height, right? The base is A. The height is not given. We need to calculate the height. So how do we calculate this one? We're gonna use the special right triangle, right? So this one right here actually 60 degrees. Right? This one right here actually 30 degrees. Right? The side length opposite to 60 degrees equals the side of the triangle times √3 divided by 2. So we're going to substitute over here 1/2 times base. The base is A right here. Times the height is going to be right here. A √3 over 2. Right? Now we're going to simplify this one. It's going to be A squared √3 over 4. Right? So make sure you know this formula. Now, isosceles right triangle. If this one A, this one should be A. Right? This one is the right angle, right? So the error is 1/2 a square, right? Base equals a, the height is still the same, right? Now, to find the hypotenuse right here, I call the hypotenuse s, right? I'm going to use Pythagorean theorem, so I have s squared equals a squared plus a squared, right? So it could be 2a squared. Check square root both sides. S equals a root 2. Keep that in mind. Alright, the volume of the solids with known cross sections. For cross sections of error A of S taken perpendicular to the S-axis, this is extremely important. You have the volume equals the interval from A to B of A of S, right? This one is the error of the cross section ds. Make sure this guy and this guy must be the same, right? Now for cross sections of error A of Y taken perpendicular to the y-axis, and then you have the volume is the interval from C to the A of Y dy. This guy and this guy must be the same, right? Now let's take a look at this table right here. Suppose I have the x and y coordinate right here, right? Now suppose I have two functions. The first function is going to be like this. The second function is going to be something like this. Alright. Now I need to calculate the volume of the solid where the cross section is perpendicular to the x-axis, right? And the cross section is the square, right? So it's going to be something like this. Alright, and you keep drawing the square. Then the solid should be something like this. Right? You know that the side length of the square is right here. Right? It's going to be upper function subtract the lower function, right? The upper function right here, I call this is yt, which means y top. The lower function right here, which means y bottom, right? So x right here is y top subtract y bottom, right? Then the error is x squared or y top subtract y bottom all together square, right? Now, in order to calculate the volume of the solids, you need to calculate the interval from A to B, right? This one from here is going to be A. This one right here is going to be B, right? Of x squared, actually this one is going to be y top subtract y bottom all together square, right? Similarly, the rectangle is going to be exactly the same thing, right? Base times height, right? The base is y top subtract y bottom. The height could be a constant or the function in terms of s, right? So depending on the problem, we're gonna take a look at the symbol later, okay? Now next one, the semicircle. Alright, diameter of the semicircle is the difference between the y top and y bottom, right? Then the cross section should be something like this. Now I'm gonna call the diameter of the semicircle d, right? D equals y top subtract y bottom. Makes sense. Now I need to find the radius, so does that mean the radius equals half of diameter? It's going to be 1/2 y top subtract y bottom, right? R square, right? Remember, in the first one right here, I let s be yt minus yb, right? So this guy does that mean it's going to be 1/2 s, right? Then the error is 1/2 pi r square, right? Because this is the semicircle. Alright, so does that mean 1/2 pi r equal this one right here, right? So I'm going to square this one. So it turns out to be 1/2 pi times s squared over 4. That's why I get this one right here, right? Now, in order to calculate the volume of the solid, I'm going to use the formula right here. right? So it's going to be the integral form a to b s squared ds. This one is the constant. I'm going to bring this one to the front, right? Again, s squared right here actually y t minus y b, right? The top function subtract the bottom function and then you square, right? Now, next one, equilateral triangles. We have the formula right here, remember? So, it's actually v equals root 3 over 4 integral from a to b of y t minus y b square ds, right? If you look at this one right here, the cross section should be something like this. Alright, now let's move on to the next one, isosceles right triangle with leg in the base. Alright, the isosceles right triangle is something like this. Alright, this one is S, this one should be S, right? And this one is called the leg, right? Now the leg in the base, so it's gonna be something like this. Alright, the right angle should be right here. Now the error is to be base times height, right? So base right here, height right here. Now the base and the height should be the same because this is isosceles right triangle, right? The length in the base, right? The base here. So the base is gonna be the difference between two functions right here, y top subtract y bottom, right? Y bottom, right? And remember, this guy and this guy must be the same. So base times height is gonna be s times s is gonna be s squared, right? Or it's gonna be 1/2 parenthesis y top subtract y bottom square, right? And when you calculate the volume, you're gonna put 1/2 to the front, right? And the integral from a to b of this one right here, right? So it could be 1/2 integral from a to b of y top subtract y bottom all together square, right? Now we're gonna talk about the last one, really, isosceles right triangle with hypotenuse in the base, right? So previously we know that the isosceles right triangle hypotenuse is s equals a root 2, right? Where's the length is a, right? So we go back over here. Hypotenuse is s, right? So we just say s equals a root 2, right? We look at the figure right here. Suppose this one is a isosceles right triangle, right? We have a root 2 right here equals y top subtract y bottom. Divide both sides by root 2 is going to be y top subtract y bottom divided by root 2, right? So the error is 1/2 y top subtract y bottom divided by root 2. This one is one leg. Another leg is y top subtract y bottom divided by root 2, right? Remember, s right here is y top subtract y bottom, right? So then you have 1/4 times y top subtract y bottom square, right? And it's going to be right here. Now the volume is going to be this guy right here. Substitute over here. Integral from a to b of s squared ds times 1/4, right? Now let's take a look at the first example. Find the volume of a solid in which the base is the region bounded by the graphs of this guy and this guy, right? So we need to sketch these two graphs right here, right? So this guy actually the linear function. I just rewrite this one as negative 1/2 s plus 1, right? So we have the y-intercept is 1, right? And then the slope is negative 1/2, right? So it's going down by 1 and go to the right by 2. So it could be something like this. Now the second one right here, I rewrite this one as 1/2 s minus 1, right? So if you graph this one, the y-intercept is negative 1, so it could be right here. go up by 1, go to the right by 2, so it could be right here, right? And the third one, as for 0, this one actually the y-axis, right? So it could be right here. S equals 0, right? Now I need to name this one. This one is f of s, and this one is g of s. Alright, now the base is bounded by these three graphs, right? So this one is the base. Now, question 8. The cross sections perpendicular to the x-axis are square, right? So you see that it's gonna be something like this, the square. Alright, now you can use Desmos to visualize the problem. Alright, so I'm gonna print it up right here. I'm gonna leave the link in the description. Make sure you check it out. Alright, now I just changed the name of the function right here, f of s. Now f of s is negative 1 half s plus 1, and g of s is 1 half s minus 1, right? So you have f of s is negative 1 half s plus 1, g of s is 1 half s minus 1, and s equals 0, which is the y-axis. Then you're gonna scroll down, you need to restrict the domain, right? Domain is from 0 to 2. If you look at this one right here, 0 is right here and 2 right here is the intersection between two graphs, right? Alright, so s equal a equals 0, s equal b equals 2. So make sure you have a equals 0 and b equals 2 right here. Alright, since this one is the square, you need to calculate the side length of the square. Right, so does that mean this one right here, right? So does that mean you need to take the upper one, subtract lower one. Upper one is f of s, right? So the sine equals f of s minus g of s, right? Now it's gonna be 1 minus s over 2, subtract negative 1, which is you add 1, and then you change the sign of this one, it's gonna be minus s over 2, right? So it's gonna be 2 minus s, right? Now the volume is the integral from 0 to 2 of the side length square, right? So it could be 2 minus s altogether square ds, right? Now you need to expand this one, so it could be integral from 0 to 2 of 4 minus 4s plus s square ds, right? I use the complete square formula a minus b altogether square. It's gonna be a square minus 2ab plus b square, right? So keep that in mind. If you have the plus side right here and this one's right here, must be plus side, right? Now I'm gonna check antiderivative of this one, so it could be 4s minus 4 times s squared over 2 plus 1/3 s cubed, right? Evaluated from 0 to 2. Alright, now 4 divided by 2 is gonna be 2 right here, so I need to erase this one. I put 2 right there. Alright, substitute 2 for s, so it could be 8 minus 8 plus 8 over 3. Substitute 0 for s, it could be 0, right? So the answer is 8 over 3. Now let's move on to the next one. The cross sections perpendicular to the x-axis are semicircle. Alright, so I'm going to use Desmos. The semicircle should be right here. Alright, so I change the function right here. Now don't forget to change the upper bound and lower bound right here. Right, s for a, s for b. A equals 0, right? And b equals 2. Alright, so it can be right here. Look. So you have infinitely semicircle, where diameter is the difference between the function f of s and g of s, right? So I'm going to go back over here. So you know that f of s subtract g of s is 2 minus s, which is you calculated above right here, right? Now this one is diameter, right? So this one diameter. Now you need to find the radius. So the radius is 1/2 2 minus s, right? Now you need to calculate the area of the semicircle. So area equals 1/2 pi times r squared. R equals this one, right? So multiply by 1/2 times 2 minus s all together square. Now I'm going to simplify this one. It's going to be 1 over 8. So it's going to be pi over 8 times 2 minus s all together square, right? Now the volume should be the integral from 0 to 2 of this one right here, right? So it could be pi over 8, I put pi over 8 in the front, right? Times 2 minus s all together square ds, right? This guy right here is 8 over 3, we calculate above, right? So it could be pi over 8 times 8 over 3, right? Now 8 and 8 cancel out, the answer should be pi over 3, right? Now question C, the cross sections perpendicular to the x-axis are rectangles whose the height are 3, right? So go back over here, the height is right here, is 3. The base right here is the difference between the function f of s and g of s, right? So the error is base times height. The height is given, right? So you have the base is difference between f of s subtract g of s. Keep in mind the top subtract the bottom is still 2 minus s, right? Then you have the error is base times height. It's going to be the height is 3 right here, right? So I multiply this one, it's going to be 6 minus 3s. The volume should be the integral from 0 to 2 of 6 minus 3s ds, right? Now I need to calculate this one, so antiderivative of 6 is going to be 6s, antiderivative of negative 3s is going to be negative 3 over 2s squared, evaluated from 0 to 2. Alright, substitute 2 for s is going to be 12 minus, substitute 2 for s right here, it's going to be 4 divided by 2, it's going to be 2, so it could be minus 6. Substitute 0 for s, it's going to be 0, right? So the answer is 6, right? Now let's move on to question D. The cross sections perpendicular to the x-axis are equilateral triangle, right? So again, the base is still 2 minus s, right? Because it's going to be different between f of s and g of s, right? Now, since this one is the equilateral triangle, you know that the base is actually the side, right? So it's going to be, now the error formula of the equilateral triangles with the side A. It's going to be A square root 3 over 4, right? So you have the error of this one should be 2 minus s altogether square times root 3 over 4, right? So the volume should be the integral from 0 to 2 of 2 minus s altogether square ds, and I'm going to put root 3 over 4 in the front, right? Now this guy right here actually 8 over 3. We calculated above, right? So it could be root 3 over 4 times 8 over 3, right? So simplify 8 and 4 here, it could be 2. So it could be 2 root 3 over 3, right? Let's move on to example number 2. A circular base. Find the volume of the solid in which the base is the circle, center at the origin with the radius 2 units, whose cross-section are described right here. Alright, so first you need to write the equation of the circle with the radius 2, center at the origin, right? We have the standard form of the circle equation. It's going to be s minus h altogether square plus y minus k altogether square equals radius square, where h and k is the coordinate of the center, and the radius is square root of the number on the right hand side right here, right? Now the circle center at the origin, which is 0, 0, is the coordinate of the center, right? So which is h, k equals 0, 0, right? Now the radius is 2. So when you plug it in over here, you need to square because it's radius square, right? So I have s square plus y square equals 4, right? Now I need to solve for y. Alright, so I need to subtract s squared both sides, so y squared equals 4 minus s squared. Now I need to take square root both sides, so does that mean I have y equals plus and minus square root of 4 minus s squared, right? Now I need to sketch the circle, right? The radius is 2, so 2 right here. Alright, so you have the circle, something like this. Now the upper semicircle is the one above the axis, so it could be right here. So the equation of this one should be y equals square root of 4 minus s squared, right? And the lower one is the red one, right? So it could be y equals negative square root of 4 minus s squared, right? The cross sections perpendicular to the x-axis are square, right? So you see the cross section is going to be something like this. Alright, so the side of the square is the difference between the upper semicircle and the lower semicircle, right? So it's going to be square root of 4 minus s squared subtract negative of square root of 4 minus s squared, right? So it could be 2 times square root of 4 minus s squared, right? You need to find the error of this square, so the error is square this one equal 4. Square this one is going to be 4 minus s squared. Now the volume is the integral from negative 2 to 2, right? From here to here. Of the error right here, right? It's going to be 4 times 4 minus s squared ds, right? This guy actually 2 times the integral from 0 to 2 of 4 times 4 minus s squared ds, right? Now 4 times 2 is going to be 8, right? Antiderivative of 4 right here is going to be 4s. Antiderivative of this one is going to be negative 1/3 s cubed. Evaluated from 0 to 2, right? Now I substitute 2 for s, so it will be 8 times 8 minus 8 over 3, right? Substitute 0 for s, it could be 0, right? So if I simplify this one, it could be 64 minus 64 over 3, right? And if you simplify this one, it's actually 128 over 3. Let's move on to question B. The cross sections perpendicular to the x-axis are semicircle, right? Now, if you sketch this one, it's going to be something like this. Alright. It looks like this one right here. But the base is the circle, right? Diameter should be this guy right here. The difference between the upper function and the lower function, right? So you still have diameter is going to be right here. Alright, so it could be 2 square root of 4 minus s squared, right? And then you need to find the radius, so the radius is square root of 4 minus s squared, right? Now you need to find the error, it's going to be 1/2 pi times r squared, which means 4 minus s squared, right? Because you square this one, it's going to be this one, right? Now the volume is going to be the integral from negative 2 to 2 of this one right here, right? So 1/2 pi, I'm going to put in the front pi over 2. So I have 4 minus s squared ds right here, right? Now this one turns out to be pi over 2. Alright, so this one is symmetric about the y-axis, so this turns out to be the integral from 0 to 2 of 2 times 4 minus s squared ds, right? So this guy turns out to be pi times the integral from 0 to 2 of 4 minus s squared ds. And then this guy turns out to be pi times 4s minus 1/3 s cubed evaluated from 0 to 2. Substitute 2 for s, it will be pi times 8 minus 8 over 3. Substitute 0 for s, it will be 0, right? So this guy turns out to be 16 pi over 3, right? Now let's move on to question C. The cross sections perpendicular to the x-axis are equilateral triangle, right? So you know that the side length is going to be different between the upper function and the lower function, right? So the side is 2 times square root of 4 minus s, which you calculated above, right? And the area of the equilateral triangle should be 2 square root of 4 minus s squared right here, all together square times root 3 over 4, right? Now 2 square equals 4, 4 and 4 right here cancel out, right? This one square equals 4 minus s squared, right? So I have 4 minus s squared, right? I need to multiply by root 3 right here, right? The volume is the integral from negative 2 to 2 of this guy right here, right? So I put root 3 in the front times 4 minus s squared ds, right? Again, since this one is symmetric about the y-axis, right? So it will be root 3 times 2, right? Integral from 0 to 2 of 4 minus s squared ds, right? So it will be 2 root 3. Antiderivative of 4 is going to be 4s. Antiderivative of this one is going to be 1/3 s cubed evaluated from 0 to 2. Substitute 2 for s, it will be 2 root 3 times 8 minus 8 over 3. Substitute 0 for s, it will be 0, right? So the final answer is 32 root 3 over 3, right? Now question D. The cross sections perpendicular to the x-axis are a isosceles right triangle whose hypotenuse reside along the base. Alright? So I must get the function again. It's going to be right here. Right? The hypotenuse reside along the base. So this one hypotenuse right here. This one is a isosceles right triangle. Alright? So it could be something like this. Alright, and if you keep drawing, it's gonna be something like this. Now you need to calculate the area of one isosceles right triangle, right? So we have the formula right here. We calculated above. It's right here. Hypotenuse in the base, right? It's gonna be 1 over 4 s squared, right? So area is 1 over 4 times s squared, where s is the difference of the upper semicircle and the lower semicircle, right? So it could be 1 over 4. Now, to get rid of confusion, right? So I just change this one to A. So it helps you, right? Where A is the difference between this guy, right? Remember, y equals square root of 4 minus s squared. This one is y equals negative square root of 4 minus s squared, right? I take this one and subtract this one. Doesn't mean I get 2 times this one, right? So it could be 2 times square root of 4 minus s squared all together squared, right? So if I square this one, I get 4. 4 and 4 cancel out, right? So this one turns out to be 4 minus s squared, right? So the volume is the integral from negative 2 to 2 of 4 minus s squared ds, right? And then this guy turns out to be 2 times the integral from 0 to 2, right? 4 minus s squared ds. Take antiderivative of this one, so it could be 2 times 4s minus 1/3 s cubed evaluated from 0 to 2. Substitute 2 for s, so it could be 2 times 8 minus 8 over 3. Substitute 0 for s could be 0, right? So this guy turns out to be 32 over 3. Now, the next one, the cross sections perpendicular to the x-axis are isosceles right triangle with a leg residing along the base, right? In the previous one right here, you have the right angle should be right here, right? Now, for this one, I'm going to draw another picture right here. A leg residing along the base, right? So this is the leg. Another leg should be somewhere right here, right? So you have the right angle right here. You see that? And hypotenuse should be like this, right? And you keep drawing. And you know that the side length of the leg is the difference between the upper function and lower function, right? It's gonna be this guy right here, subtract this guy, right? Alright, so it's gonna be 2 square root of 4 minus s squared, right? Alright, now since this one is an isosceles right triangle, right? So which means this guy right here and this guy right here must be the same, right? And a leg residing along the base. So this is the leg right here, the leg right here. Alright, so the error is base times height divided by 2, right? 1/2. Base is 2 times square root of 4 minus s squared, right? And the height is going to be same thing, right? This one is the base. The height is right here, right? Because this one is an isosceles right triangle, right? So you need to multiply by 2 square root of 4 minus s squared, right? Now if you simplify, it's going to be 2 times 4 minus s squared, right? Now the volume is the integral from -2 to 2 of 2 times 4 minus s squared ds, right? So this guy turns out to be 2 times the integral from 0 to 2 of 2 times 4 minus s squared ds, right? 2 times 2 is equal 4, right? Now take antiderivative of 4, it's going to be 4s. Antiderivative of negative s squared is going to be negative 1/3 s cubed. Evaluated from 0 to 2, right? Now it's going to be 4 times 8 minus 8 over 3, right? And then it's going to be 64 over 3. This one is the final answer, right? Now let's move on to example number 3, an irregularly shaped base. An irregularly shaped base. Find the volume of the solid in which the base is bounded by the curves y equals s plus 1 and y equals e raised to the s over 3, right? So we're going to graph this one right here and this one right here on the calculator, right? So you're going to hit add graphs right here. The first function is s plus 1. Hit enter. Now you're going to enter the second function. So hit tab. It's going to be e raised to the s over 3. Alright, so it's going to be right here. Now the intersection right here is s equals 0, y is equal 1. We need to find the intersection right here, right? So we're going to hit menu, analyze graph, number 4. Move to the left, move to the right. It's going to be right here. 5.71 and 6.71, right? Alright, question A. The cross sections are semicircles perpendicular to the axis, right? So we just draw the semicircle, right? So it could be something like this. So diameter is the top subtract the bottom, right? So you have y top subtract y bottom. It's gonna be s plus 1 subtract e raised to the s over 3, right? Now you need to find the radius, so you need to divide this one by 2. So I have 1/2 times s plus 1 minus e raised to the s over 3, right? Now you need to find the area of the semicircle, so a equals 1/2 pi times r square. So it could be 1/2 pi times this one square is going to be 1 over 4, right? Times s plus 1 minus e raised to the s over 3 all together square. Now 1/2 times 1 over 4 is going to be 1/8 times pi is going to be pi over 8 right here. Right? Now the volume is going to be the integral from the left endpoint is going to be 0. The right endpoint is going to be 5.71, right? So it could be 0 to 5.71, right? Of pi over 8 times s plus 1 minus e raised to the s over 3 all together square ds, right? Now we're going to bring up the calculator to calculate this one, right? So you're going to hit add calculator. Now press menu, calculus, integral from 0 to 5.71 of pi over 8. So you're going to press the button next to number 9 right here. Hit fraction. Pi over 8 times s plus 1 minus e raised to the s over 3 square ds. Hit enter. The answer is 1.981, right? Alright, the cross sections are semicircles perpendicular to the y-axis. Alright, so question B similar to question A. The only thing different right here is this one is the s-axis, right? Now we're gonna sketch the figure, right? Alright, now you need to rewrite every single thing in terms of y, right? Now the function y equals e to the s over 3. You need to rewrite this one in terms of y, right? So you're gonna take natural log both sides. So it could be natural log of y equals s over 3, right? Then I'm gonna multiply both sides by 3. So s equals 3 times natural log of y, right? Now for this one right here, I need to rewrite this one in terms of y. So s equals y minus 1, right? Diameter is s right subtract s left, right? This one right here, s right. This one right here, s left, right? Remember, when you calculate the diameter in question A right here, you need to take y top subtract y bottom, right? So this guy turns out to be 3 natural log of y subtract y minus 1. Now I'm going to simplify this one, so it's going to be 3 natural log of y subtract y plus 1, right? Now the radius is half of diameter, so it can be 1/2 times 3 natural log of y minus y plus 1, right? Then the error is 1/2 pi r square, r right here. So it's going to be 1/2 times 3 natural log of y minus y plus 1 all together square, right? So if I simplify this one, it's going to be pi over 8 times 3 natural log of y minus y plus 1 all together square, right? Now the volume is, since this one is in terms of y, right? So you look at the y values right here, right? The lower bound is 1. The upper bound is 6.71, right? This one right here. So it's going to be the integral from 1 to 6.71 of pi over 8 times 3 natural log of y minus y plus 1 altogether square dy, right? Now you're going to bring up the calculator, right? The integral from 1 to 6.71, right? Of pi over 8 times 3 natural log of y minus y plus 1 altogether square. Don't forget dy right here, right? Hit enter. The answer is 1.981, right? So which is the same thing as this guy right here. Alright, now let's move on to question C. The cross sections are isosceles right triangles with one leg in the regions perpendicular to the y-axis. Alright, so we're gonna sketch the figure again. Alright, if you do the right thing, it's gonna be something like this. Now, since one leg in the region, so then this guy right here and this guy right here must be the same, right? Now, the leg right here is difference between S right subtract S left, right? So it's gonna be right here. Alright, so it could be 3 natural log of y minus y plus 1, right? This leg actually the base, right? Right here. Now the height should be the same, right? So the height is 3 natural log of y minus y plus 1, right? Because this one is an isosceles right triangle, right? So the error is 1/2 base times height, which is 1/2 of this guy the same. So it could be 3 natural log of y minus y plus 1 altogether square, right? So the volume should be the integral from 1 to 6.71, right? Because this one in terms of y, right? Now I'm going to bring up the calculator. So this one right here should be 1/2. Enter. It's going to be 2.52, right? We're going to explore topic 8.9, disk method, revolving around the x or y axis. Alright, in the non-cross sections technique you learned in previous lessons, you given a base regions in the plane, and you build a solid by stacking up slices perpendicular to an axis. Each slice has a specific known shape like squares, rectangles, triangles, semicircles, etc. Then the volume is found by integrating the area of each cross-section. Now, in the disk method, it's really the same idea, but the cross-sections are specifically circles or the disk right here that come from revolving the regions around an axis. So you look at this one, if you revolve this one around the x-axis, for example, you will get the cylinder right here, right? The radius of each disk comes from the distance from an axis of revolution, which means right here to the curve, right? So the distance from here to here is the radius. The area of each cross section is A of S is pi R of S squared, right? The volume is V equals the integral from A to B of A of S, right? ds. Now you know that the formula for the volume of a cylinder is V equals pi r squared times h, right? So if you look at the figure right here, horizontal axis of revolution, the volume is right here, right? So I'm gonna write it over here, V equals pi r squared times h, right? Now, when you revolve in this one about the x-axis, you get the cylinder right here, right? So, in order to calculate the volume of the cylinder, you're gonna use this formula, right? The height is W right here, or ds, right? The radius is right here. I have V equals pi, the integral from A to B, the radius square, right? Times ds. ds actually delta s right here, right? Now, vertical axis of revolution is gonna be exactly the same thing, right? It's just in terms of y, right? So when you revolve in this one about the y-axis. Now, example number 1, using the disk method, find the volume of the solid formed by revolving the region bounded by the graph of f(s) equals square root of psi s, and the x-axis about the x-axis for s go from 0 to pi. Using the graph of f(s), shade the regions being rotated and draw a representative rectangle. Alright, so the region being rotated is right here, right? And the representative rectangle is going to be something like this. Now, if you revolve this guy about the x-axis, you will get a solid something like this. Alright, so by the formula, you have the volume equals pi, the integral from 0 to pi of square root of psi s squared, right? Because this one actually the radius, right? ds. Then it's gonna be pi, the integral from 0 to pi. When you square this one, it's actually psi s ds, right? Now take antiderivative of psi s could be negative cosine s, right? So it could be negative pi cosine s evaluated from 0 to pi, right? Now I need to rewrite negative pi, right? Substitute pi for s, it could be cosine pi, minus substitute 0 for s, it could be cosine 0, right? So I have negative pi, cosine pi equals negative 1, cosine 0 equals 1, so it could be minus 1, right? So the answer is 2 pi, right? Now let's move on to example number 2, revolving around the x-axis. Alright, so y equals negative x plus 1, we need to get this one, right? So s equals 0, y equals 1, it's going to be right here. S equals 1, y equals 0, it's going to be right here, right? So we just connect these 2 points. Alright, so the region should be this one right here. Now we need to revolve this one about the x-axis, right? So the representative rectangle is going to be right here, right? Then this one actually the radius of the solid, right? And the radius is right here, the function y, right? Now if you revolve this one about the x-axis, you will get a solid something like this. So volume equals, now we need to find the lower bound and upper bound. The lower bound is 0 right here, upper bound is 1 right here, obviously, right? In order to find this one, we just set up this one right here, y equals negative s plus 1, right? And y equals 0. The x-axis right here is y equals 0, right? We just solve a system of equations right here to get s value, right? So does that mean we need to equate this one right here, right? So I have negative s plus 1 equals 0, and then s equals 1. That's why we have this one right here, right? So the volume is pi, the integral from 0 to 1 of this one right here, square, right? And ds, which is the height, right? Now I just rewrite this one a little bit. It's going to be pi, the integral from 0 to 1 of 1 minus s altogether square ds. Then I'm going to use the complete square formula. It's going to be a minus b altogether square equals a square minus 2ab plus b square, right? So this guy turns out to be pi times the integral from 0 to 1 of 1 minus 2s plus s squared ds, right? Then I'm going to take anti-derivative of this one. It's going to be s minus s squared plus 1/3 s. Then I need to evaluate from 0 to 1, right? So it's going to be pi times, substitute 1 for s, it's going to be 1 minus 1 plus 1/3. Substitute 0 for s, it could be 0. The answer is pi over 3, right? Now let's move on to this question. Y equals square root of s from 1 to 4, right? Now s equals 0, y equals 0. We get the first point, right? S equals 1, y equals 1. Second point, right? S equals 4, y equals 2. Right here, right? Now I just connect these 3 points. Now we have restricted domain from 1 to 4, right? So 1 right here and 4 right here, right? So the region should be from here to here only, right? Now I need to sketch the representative rectangle. So it's going to be something like this. And this guy is actually the radius, right? And this one is delta s, right? Now, if you revolve this one about the x-axis, you will get the solid something like this. So v equals the integral from 1 to 4, right? Pi put in the front. Now this guy actually radius in terms of s, right? So I have square root of s altogether square, right, times ds. Right, so this guy turns out to be pi times the integral from 1 to 4 of s ds. Now take anti-derivative of this one. It's going to be pi times 1/2 s square evaluated from 1 to 4, right? So it's going to be pi over 2 times, substitute 4 for s, it's going to be 16, substitute 1 for s, it's going to be 1, subtract 1, right? So the answer is 15 pi over 2. Now let's move on to example number 3. Revolving around the y-axis. The function y equals s squared from 0 to 4, right? Now s equals 0, y equals 0. We get this one. S equals 1, y equals 1. S equals 2, y equals 4. So it could be like this, right? So if you connect these 3 points, it could be something like this. So the region should be from here to here. Now we need to sketch a representative rectangle. So it could be something like this. Alright, this one actually the radius are in terms of y, right? And this one is delta y, right? The lower bound is 0, the upper bound is 4, right? Now if you revolve in this one about the y-axis, you will get something like this. So we have volume equals pi, the integral from 0 to 4 of. So we need to rewrite this one in terms of y, right? So I have y equals s squared. Does that mean s squared equals y, right? So then I'm going to take square root both sides. It's going to be s equals plus and minus square root of y, right? Now observe that this region is above the axis from 0 to 4, right? So s should be positive, right? So we only pick s equals square root of y, right? So we put it over here, square root of y right here, all together, square dy, right? Alright, so this guy turns out to be pi the integral from 0 to 4 y dy, right? Now take antiderivative of this one, it's going to be pi times 1/2 y squared evaluated from 0 to 4, right? So this guy turns out to be pi over 2 times substitute for y is going to be 4 square. Substitute 0 for y is going to be 0, right? So the answer is 8 pi. Now let's move on to this question. Y equals s power 2/3. Now I convert this one to radical. So it's actually cube root of s squared, right? So now s equals 0, y equals 0, s equals 1, y equals 1, right? S equals 2, y equals cube root of 4, right? It's going to be something like this. So I need to rewrite s in terms of y, right? So I have s power of 2 third equals y. Now to remove this one, I need to raise to the power of 3.5 both sides, like this. Right? So this guy cancel out, this guy cancel out. So I have s equals y power 3.5, right? So the region should be this one right here. Then the representative rectangle should be this one. This one actually delta y. This one actually the radius in terms of y. And the radius in terms of y is right here. Right? Now if you revolve in this one about the y-axis, you will get something like this. So the volume should be pi times the integral from 0 to 1 right here. 0, 1, right? Of this guy right here, right? Y power 3.5 all together square dy, right? So this guy turns out to be pi times the integral from 0 to 1, 2 and 2 cancel out, so it will be y power 3 dy. Take antiderivative of this one is going to be pi times 1 over 4 y power 4 evaluated from 0 to 1, right? So it's going to be pi over 4 times substitute 1 for y is going to be 1 power 4 minus substitute 0 for y is going to be 0 power 4, right? So the answer is pi over 4, right? We're going to explore topic 8.10, volume using this method, revolving around the other axis. Let's take a look at the first example, revolving about a line that is not a coordinate axis. Right. Find the volume of the solid formed by revolving the regions bounded by the graphs. F of s equals 2 minus s squared and g of s equals 1 about the line y equals 1. Sketch the graph and draw a representative rectangle. Alright, so we need to sketch this guy first. S equals 0, y equals 2 is going to be right here. S equals 1, y equals 1 is going to be right here. S equals -1, y equals -1 is going to be right here. Right? So if you sketch the graph, it's going to be parabola, right? So it should be something like this. Now we need to catch g of x equals 1. So it's going to be the horizontal line right at y equals 1. This one is g of s equals 1. 1 right here, right? And this guy right here is going to be f of s equals 2 minus s squared, right? Now we need to revolve these regions about the line y equals 1, right? So we're gonna get the solid, it's gonna be something like this. Now we need to draw a representative rectangle. So representative rectangle is gonna be right here. Alright, this one actually the radius. Delta S is right here, right? Now, how do we find the radius? This guy is y top subtract y bottom, right? Y top is the function f of s. Y bottom is the function g of s, right? So the volume is pi, the integral from this guy to this guy, right? -1 to 1. How do you find -1 and 1 right here? We just set up a system of equation right here. It's going to be the function f of s equals 2 minus s squared, and the function g of s equals 1, right? We need to find the intersection between these two graphs, right? So does that mean you need to equate this guy and this guy, right? So I have 2 minus s squared equals 1, right? So s squared equals 1 and s equals -1 and 1. That's why you have this guy and this guy, right? Of y top subtract y bottom, which means 2 minus s squared subtract 1 altogether square ds, right? Then I need to simplify this one, so it's going to be pi, the integral from -1 to 1, right? Of 1 minus s squared ds, right? Now I'm going to use the complete square formula to expand this one, right? Remember you have a minus b altogether square. It's going to be a square minus 2ab plus b squared, right? So this guy turns out to be pi times the integral from -1 to 1 of 1 minus 2 s squared plus s power 4 ds, right? Now observe that the one inside parenthesis right here is the even function, right? So this guy turns out to be 2 pi, the integral from 0 to 1 of 1 minus 2 s squared plus s to the 4 ds. Alright, if you want to review this concept, please check out the link in the description below. Alright, so take antiderivative of this one is going to be 2 pi times s minus 2 third s cubed plus 1/5 s to the 5th evaluated from 0 to 1, right? So I substitute 1 for s, it's going to be 2 pi times 1 minus 2 third plus 1/5, right? By doing this way, I'm going to get rid of the -1 right here, right? So if you simplify this one, it's going to be 16 over 15 pi. Now let's move on to example number 2. Set up the integral that gives the volume of the solid that resolve by revolving the regions about the given lines. Y equals square root of s, y equals 0, s equals 3, right? So we're gonna sketch this one first, right? S equals 0, y equals 0. S equals 4, y equals 2. This could be right here, right? Right, so if you sketch this one, it's gonna be something like this. Now, y equals 0, this one actually the x-axis, so it could be this guy. And x equals 3, it's gonna be right here. So, the region should be this guy. Now, we're gonna revolve these regions about the x-axis, so it's gonna be something like this. Alright, so we get the solid, and the representative rectangle is gonna be this guy. This guy actually the radius, right? It's gonna be this guy right here, subtract this guy, right? So it's gonna be square root of s, right? And this one is delta s, right? So you have volume equals, now you need to find the intersection from here to here, right? It's gonna be 0 to 3 right here. So it's gonna be pi times the interval from 0 to 3 of the radius. It's gonna be square root of s right here, altogether square ds, right? So it's gonna be pi times the interval from 0 to 3. So it's gonna be pi times the interval from 0 to 3 of s ds, right? So it's gonna be pi times 1/2 s squared evaluated from 0 to 3, right? And it's gonna be pi over 2 times substitute 3 for s, it could be 9. Substitute 0 for s, it could be 0. So the answer is 9 pi over 2, right? Now, let's move on to question B. You need to revolve the regions about the line s equals 3. Alright, so I'm going to sketch this one again. Now, the representative rectangle, it should be this guy. Right, this is delta y. And this one actually the radius in terms of y, which means arc y. So arc y equals s right subtract s left, right? S right, which means 3 right here. So it could be 3 subtract s left, which is the function y equals square root of s right here. We need to rewrite this one in terms of y, so I square both sides. So I have y square equals s, or s equals y square, right? So this one minus y square, right? Now I need to find the intersection right here, right? So I need to solve a system of equation between y square equals s, right? So s equals y square and s equals 3 right here, right? Then I have this guy and this guy must be the same, right? So y square equals 3. Check square root both sides, so y equals plus and minus root 3, right? But this guy right here is positive, right? So you're gonna pick y equals root 3, right? So volume is from 0 to this one right here, root 3, right? So it's gonna be pi times the interval from 0 to root 3 of y square dy, right? Now I substitute value pi times the interval from 0 to root 3 ry equals this one right here, 3 minus y square altogether square dy. Now you're going to use the complete square formula to expand this one, right? So it's going to be pi times the interval from 0 to root 3 of 9 minus 6y square plus y power 4 dy, right? So it's going to be pi times, take entire derivative of this one, it's going to be 9y minus 2y power 3 plus 1/5 y power 5 evaluated from 0 to root 3, right? So it's going to be pi times 9 root 3 minus 6 root 3 plus 9 over 5 root 3, right? Substitute 0 for y is going to be 0, right? So I simplify this one, it's going to be 24 pi root 3 over 5. This one is the final answer. We're going to explore topic 8.11. What's the method revolving around the s or y axis? Alright, to find the volume of a solid of revolution with the Wash method, use one of the following. The first one, horizontal axis of revolution. So suppose you have two functions f of s, it could be something like this. And the function g of s is going to be something like this. Now, two functions intersect at the points right here. Alright, so it's create a regions. Now, we need to revolve these regions about the x-axis, right? So we get the solid something like this. When you see a hole in the middle right here, then you're going to use the Gaussian method, right? So basically, the volume is going to be pi the integral from a to b of the bigger radius, which means the outer radius, right? The distance from the outer function right here to the center. The center is the axis of revolution, right? So the center is right here. So the distance from here to here is the outer radius. Subtract the inner radius, which means the lower function right here, to the center of rotation, right? So it could be from here to here is the inner radius. So that's why you have the formula right here. Now look at the right hand side. Suppose I have the function f of s is right here, and the function g of s is right here. Alright, now the shaded region should be this one. If I want to revolve this one about the y-axis, right? So I will get this solid something like this. The center of rotation is the y-axis right here, right? So the distance from the right function to the y-axis is the bigger radius, right? The difference from the left function to the y-axis is the inner radius, right? So it could be capital R in terms of y square minus little r in terms of y square dy, right? So you have the formula right here. Now let's move on to example number 1. Using the Gaussian method, find the volume of the solid formed by revolving the region bounded by the graphs f of s equals square root of s and y equals s squared about the x-axis. Sketch the graph and draw a representative rectangle. Now to sketch this one, we're gonna let x equals 0, y equals 0, right? X equals 1, y equals 1, right? So if you graph it, it's gonna be something like this. Now, to graph this one, we're gonna let x equals 0, y equals 0, right? X equals 1, y equals 1, right? X equals 2, y equals 4, right? So if you graph it, it could be something like this. And the shaded region should be this guy. Now, we need to find the intersection between these two graphs manually, right? So we're gonna let s squared equals square root of s, right? Then we're going to square both sides, so we have s power 4 equals s, right? Then I'm going to subtract s both sides, so I have s power 4 subtract s equals 0, right? Factor s out, so it's going to be s cubed minus 1 equals 0, right? So then s equals 0 and s power 3 minus 1 equals 0, right? Then you have s equals 0 and s equals 1, right? That's why you have this guy right here, 1 and 0 right here, right? Now we need to revolve this one about the x-axis, so you're gonna get the solid something like this. The outer radius is the distance from the top function to the center of rotation, so it could be right here. This one is r s, right? The inner radius is the distance from the inner function to the center of rotation, right? So this one is little r of s, right? Now the inner function is y equals s squared, right? The outer function is y equals square root of s, right? So the volume is pi times the integral from 0 to 1. The bigger radius, which is the outer function right here, right? square root of s altogether square minus the smaller radius, which is this guy right here, s square altogether square ds, right? Now, if you simplify, it's going to be pi, the integral from 0 to 1, s minus s power 4 ds, right? Take antiderivative of this one is going to be pi times 1/2 s squared minus 1/5 s power 5, right? Evaluated from 0 to 1. Now substitute 1 for s is going to be pi times 1/2 minus 1/5, right? Substitute 0 for s is going to be 0, right? So the answer is 3 pi over 10. Now let's move on to question B. We're going to revolve these regions about the y-axis. Alright, so if you sketch a graph, it's going to be something like this. Let's get the representative rectangle. You know that the center of rotation is the y-axis, right? So the outer one is right here. This one is ry. And the inner one is right here. This one is little r y, right? Now, you know that the lower bound is 0 and the upper bound still 1, right? Now the outer function is y equals s squared. The inner function is y equals square root of s, right? You need to rewrite this one in terms of y, right? So I have y equals s squared. It's the same thing as s squared equals y, right? Take square root both sides, so it could be s equals plus and minus square root of y, right? Because this one is above the axis, so we're gonna take s equals square root of y, right? Now y equals square root of s, then square root of s equals y, right? Now you're gonna square both sides, so s equals y squared, right? So the volume is pi times the integral from 0 to 1, right? This one to this one right here, right? The bigger radius is the one right here, right? Which means square root of y, right? The smaller radius is this guy. It's going to be y squared, right? So we have square root of y altogether square minus y squared altogether square dy, right? Now I'm going to simplify this one. It's going to be pi times the integral from 0 to 1 y minus y power 4 dy, right? So take antiderivative of this one is going to be pi times 1/2 y squared minus 1/5 y power 5 evaluated from 0 to 1, right? So it's going to be pi times 1/2 minus 1/5, and it's going to be 3 pi over 10, right? Which is the same thing as the first one right here, right? Now let's move on to example number 2. Integrating with respect to y, two integral case, disk and quotient methods combined. Alright, find the volume of the solid formed by revolving the regions bounded by the graphs y equals s squared plus 1, y equals 0, s equals 0, and s equals 1 about the y-axis. Alright, now we're gonna sketch this one first, right? S equals 0, y equals 1. S equals 1, y equals 2. S equals negative 1, y equals 2. Right? So it could be something like this. Now y equals 0, which is the x-axis, right? Now s equals 0, which is the y-axis, right? So it could be this guy. S equals 1, which is this guy. Now the shaded regions is this guy. Now if you revolve this one about the y-axis, it's going to be something like this. Now we're going to split this solid into two shapes, right? The first one is from here to here. Right? So this one right here, we're going to use this method because we don't see the hole, right? This one right here, we're going to use the washer method. Now, I call these regions A, I call these regions B, right? So, from 0 to 1, I have the radius right here. The radius in terms of y actually 1, right? Because the right one right here subtract the left one, which is 0 right here. 1 subtract 0 equals 1, right? So the volume of the solid A is pi, then 0 from 0 to 1, right? 0 right here and 1 right here. 1 square dy, right? So it's going to be pi y evaluated from 0 to 1, so it could be pi, right? Now, the volume of the solid B right here, we're going to use washer method, right? Because we have the hole in the middle right here, right? So, the bigger circle is right here, right? And the smaller circle is right here, right? So, we need to draw two representative rectangles, right? The first one is right here. This one is the bigger radius, so this one is called capital R Y, right? Capital R Y equals 1, right? Because it's going to be S right subtract S left, right? S right is 1, S left is 0 right here. That's why you get 1. Now, the smaller radius is right here, right? This one is little r y equals s right subtract s left, right? It's going to be s right is the quadratic right here. So we have the quadratic, it's going to be y equals s squared plus 1. We need to rewrite this one in terms of y, right? So I have s squared plus 1 equals y. It's the same thing as s squared equals y minus 1. Take square root both sides, so have s equals plus and minus square root of y minus 1, right? But we only take the positive one, right? So we have s equals square root of y minus 1, right? So this one is square root of y minus 1. Subtract s left, which is 0 right here, right? Because the center of rotation, right? So it's going to be square root of y minus 1. That's it, right? So volume of the solid B is pi times the interval from 1 to 2 right here, right? Of the bigger radius, which is 1 right here, square. Subtract the smaller radius, which is square root of y minus 1 right here. Altogether square dy, right? Now I'm going to simplify this one. It's going to be pi times the interval from 1 to 2 of 1 minus y. When you square this one, it's going to be y minus 1, and you distribute negative 1 right here. It's going to be negative y plus 1, right? dy. Now 1 plus 1 is going to be 2, so I just write 2 over here. Alright, so this guy turns out to be pi times 2y minus 1 half y squared evaluated from 1 to 2, right? So I substitute 2 for y is going to be pi times 4 minus 2, right? Minus substitute 1 for y is going to be 2 minus 1 half, right? Now I'm going to simplify. It's going to be pi times 4 minus 2 is going to be 2. 2 minus 1 half is going to be 1.5, right? And it's going to be 0.5 pi or pi over 2, right? Now you need to add this guy right here and this guy right here. So the final volume should be pi plus pi over 2 equals 3 pi over 2. This one is the final answer. We'll explore topic 8.12. What's the method? Revolving around the other axis. Alright, so remember we learned before, we have the volume formula. When you revolve the regions about the horizontal axis, it's going to be V equals pi integral from A to B. The bigger radius square minus the smaller radius square ds, right? So when it's come to the horizontal axis, it's going to be S value, right? Similarly, the vertical axis of revolution, the volume is given by pi times the integral from C to D of bigger radius square minus the smaller radius square, and in terms of y, right? Now remember the Watson method, you always have a hole in the middle, right? Now let's take a look at the first example. What's the method using other axis revolution number 1? Alright, find the volume of the solid formed by revolving the regions bounded by the graphs y equals s squared plus 1, which is the blue one right here. Y equals 0, which is the x-axis right here. S equals 0, which is the y-axis right here. And s equals 1, which is this guy right here. About the line s equals -1. Alright, so s equals -1 is the axis of revolution, right? So I call this one A, O, V. Alright, shade the regions being revolved, draw the axis of revolution, and draw the representative rectangles for capital R and the little r, right? So the shaded region should be this guy right here. Now s equals -1 is the axis of revolution, so it's going to be right here. Now when you revolve this one about this line, it's going to be something like this. Alright, so I need to separate this guy into two regions, right? The bottom is going to be from here to here, and the top should be from here to here. Alright. Now the bigger circle for the radius is going to be the bottom one right here, and the smaller circle is going to be right here. Now we need to get the rectangles right here. So the bigger rectangles is going to be from here to here, and the smaller rectangle is going to be from here to here, right? Volume of the solids is V1 plus V2, right? V1 is the yellow ones right here. V2 is the green one right here, right? Now you have V1 equals pi, the integral form. Now you need to be careful when it comes to the vertical axis of revolution. Your volume should be in terms of y. So the upper bound and lower bound should be right here, 1. And this one should be 0, right? So it could be the integral from 0 to 1, right? Bigger radius in terms of y square minus the smaller radius in terms of y altogether square dy, right? Keep that in mind. Now the bigger radius is s right subtract s left, right? S right is right here, s left is right here, right? So it's going to be pi, the integral from 0 to 1. S right is 1, s left is -1, right? So it could be 1 minus -1 altogether square, right? Subtract the little r right here. S right is the y-axis right here, which is s equals 0, right? So it could be 0 minus s left is right here, -1, right? So subtract -1 altogether square dy, right? Then it's going to be pi, the integral from 0 to 1. It's going to be 4 minus 1 altogether dy, right? So it's going to be pi times the integral from 0 to 1 of 3 dy. 3 pi times y evaluated from 0 to 1. So the answer is 3 pi. Right, now v2 equals pi times the integral from here 1 to this guy right here. Alright, so we need to find the intersection right here between the parabola y equals s squared plus 1 and the vertical line s equals 1 right here, right? So I'm going to put this one on the side note. So I have the system of equation y equals s squared plus 1, s equals 1, right? Substitute 1 for s, so I have y equals 2, right? So v2 equals pi times the integral from 1 to 2, right? Now the bigger radius is still this guy right here, right? So which is s right subtract s left, right? So it's gonna be 1 subtract negative 1 altogether square minus the smaller radius is depending on the graph right here, right? Now remember that this one must be in terms of y, right? Because the representative rectangles perpendicular to the vertical axis, right? So you need to rewrite this one in terms of y, right? So I have y equals s squared plus 1, then s squared equals y minus 1, right? Take square root both sides, so s equals plus and minus square root of y minus 1, right? Now you look at this one right here, it's gonna be on the right of the y-axis, so it should be positive. So you need to eliminate the negative side right here, right? So it's gonna be square root of y minus 1 minus, right? This one is the right. The left hand side is right here. Alright, so subtract negative 1 square dy, right? Now I'm going to simplify this one, so it's going to be pi, the integral from 1 to 2 of 4 minus square root of y minus 1 plus 1 altogether square dy, right? Now to find the answer for this one, you can calculate this one by hand, or you can use a calculator. So I'm going to print up the calculator to calculate this one faster. Alright, so I'm going to add calculator and I'm going to press menu, calculus, integral from 1 to 2. Don't forget to multiply by pi, right? So I put pi in the front. And I hit enter. The answer 7 pi over 6, right? Alright, so the final answer is 3 pi plus 7 pi over 6. Alright, so it could be 25 pi over 6. Now let's move on to example number 2. We're gonna revolve these regions about the line y equals negative 2. Alright, so y equals negative 2 is gonna be right here. Alright, so here's the complete solid after the revolution, right? So the axis of revolution is y equals negative 2, right? And this is horizontal axis, right? So if this horizontal axis, the volume should be in terms of s, right? And the representative rectangles must be perpendicular to the axis of revolution, right? So the bigger radius is right here, right? And the smaller radius is right here, right? In this situation, you don't need to split this one into two integrals, right? So the volume should be pi. The integral from here to here, which means from 0 to 1 of the bigger radius, right? The bigger radius depending on this guy right here, right? Subtract this guy right here, right? But this guy right here is going to be y equals s squared plus 1, right? So you have s squared plus 1. Subtract y equals negative 2, right? Subtract negative 2 all together squared minus the smaller radius, which is this one, y equals 0, right? Remember, y top subtract y bottom when it comes to the horizontal axis of revolution, right? S right subtract S left when it comes to the vertical axis of revolution, right? So this guy turns out to be 0 minus negative 2 altogether square ds, right? Now I'm going to simplify this one. It turns out to be pi times the interval from 0 to 1 s squared plus 3 altogether square minus 4, right? ds. Now I'm going to use the complete square formula to expand this one. So it could be pi times the interval from 0 to 1 s power 4 plus 6s squared plus 9. Subtract 4 is going to be 5, right? ds. Now remember, the complete square formula is going to be a plus b altogether square is going to be a square plus 2ab plus b square, right? Now take anti-derivative of this one is going to be pi times 1/5 s power 5, right? Plus 2s cubed, right? Plus 5s evaluated from 0 to 1, right? So it's going to be 1/5 plus 2 plus 5 times pi, right? Substitute 0 for s is going to be 0. Now I'm going to simplify this one. It turns out to be 36 over 5 pi. This one is the final answer. Now let's move on to example number 3. Now in this situation, we're going to revolve the regions about the line s equals 2. Alright, so this one is similar to the first example, right? The first example, we're going to revolve about the line s equals -1, right? Now we need to revolve this one about s equals 2. So it could be right here. Alright, so you're going to sketch the solid. It's going to be something like this. Now again, we need to split this solid into two regions, right? The first one is from 0 to 1, right here, right? The second one is from 1 to 2, right? So I call this one is V2. This one is V1, right? Similar to example number 1, right? So I have V equals V1 plus V2, right? Now, V1 is pi times the interval from 0 to 1, right? S right subtract s left, right? Square minus s right subtract s left square dy, right? So it's going to be pi times the interval from 0 to 1. Now remember, the axis of revolution is s equals 2 right here, right? So the bigger radius is from here to here, right? So it's going to be 2 minus 0 altogether square, right? Now the smaller radius is from here to here, right? So it's going to be 2 minus 1 all together square dy, right? And it's going to be pi times the interval from 0 to 1, 2 square equals 4. 4 minus 1 is going to be 3, right? So it could be 3 dy. And it's going to be 3 pi times y evaluated from 0 to 1. It's going to be 3 pi, right? So V1 equals 3 pi. Now V2 is the green one right here. Now, in this situation, the bigger radius is dependent on the graph right here, right? This one is y equal s squared plus 1. In the example number 1, we rewrite this one in terms of y. It turns out to be square root of y minus 1, right? S equals. Now, the bigger radius is the radius of the bigger circle. It's going to be right here, right? It's dependent on the graph of this one right here, right? And the smaller radius is right here. Alright, so you have pi times the integral form. In this situation should be 1 to 2, right? The bigger radius is the distance from here to here, right? So it's going to be 2 minus square root of y minus 1 all together square. Subtract the smaller radius. It's going to be this guy right here. 2 minus 1 square dy, right? And you're going to simplify this one. It turns out to be pi the integral from 1 to 2 of 2 minus square root of y minus 1 all together square minus 1. Now you're going to bring up the calculator. Enter the expression right here and then hit enter. The answer is 5 pi over 6. Right? And then V equals V1 plus V2. V1 is 3 pi, right? And V2 is 5 pi over 6, right? So the answer is 23 pi over 6, right? Now let's move on to example number 4. Find the volume of the solid formed by revolving the region bounded by the graphs y equals s squared, y equals s power 5 about the line y equals 0. So y equals 0, which means the x-axis. So this guy becomes the axis of revolution, right? Shade the region being revolved. Draw the axis of revolution and draw the representative rectangles for capital R and little r, right? So y equals s squared is going to be something like this. S equals 1, y equals 1. S equals 2, y equals 4, right? So it could be something like this. Now, y equals s power 5 is going to be something like this. Then, the shaded region should be this guy right here. Now, we need to revolve this one about the x-axis, right? So, it turns out to be something like this. Alright, so the smaller radius is the distance from here to here, right? This one is the representative rectangles, little r, right? And the bigger radius is going to be from here to here, right? So volume is pi times the integral from 0 to 1 right here. How do we get 1? Because the intersection between these two graphs right here should be 1, right? We can solve a system of two equations. Y equals s squared and y equals s power 5, right? So it turns out to be s squared equals s to the 5th, right? And subtract s to the 5th both sides, so have s squared minus s to the 5th equals 0. Factor s squared out. 1 minus s cubed equals 0, right? So s squared equals 0 and 1 minus s cubed equals 0. Now you solve this one, s equals 0 and this one s equals 1. That's why you get 0 and 1 right here, right? So the volume is pi times the interval from 0 to 1, right? The biggest radius in terms of s subtract the smaller radius in terms of s squared, right? ds. So it's going to be pi times the interval from 0 to 1. The bigger one is the blue one right here, right? So it's the difference between y equals s squared and the x-axis, which means y equals 0, right? So you have s squared minus 0 all together square. Subtract. The smaller one is the black one right here, which is y equals s power 5 and the x-axis, right? So it's going to be s power 5 subtract 0 all together square ds, right? Then it turns out to be pi times the interval from 0 to 1 s power 4 minus s power 10, right? ds. Now take antiderivative of this one is going to be pi times 1/5 s power 5 minus 1/11 s power 11. Evaluated from 0 to 1. So it turns out to be pi times 1/5 minus 1/11, right? And it turns out to be 6 over 55 pi, right? Now let's move on to example number 5. We need to find the volume of the solids formed by revolving the regions bounded by the graphs y equals square root of s, right? So s equals 0, y equals 0 is going to be right here. S equals 1, y equals 1, right? And s equals 4, y equals 2. So it could be something like this. Alright, y equals 0, which is the x-axis, right? Y equals 0 right here. And s equals 3, so it could be right here. Right? So the region should be this guy. Now, when the y-axis is the axis of revolution, the solid should be something like this. Alright, so the bigger radius is right here. And the smaller radius is right here. Right? Now, you need to rewrite this one in terms of y because you revolve these regions about the vertical axis, right? This guy is y equals square root of s, right? You write over here y equals square root of s, right? So square both sides, so it could be s equals y squared, right? And this one right here, s equals 3, right? So you need to find the intersection right here. In order to find the intersection right here, you need to solve a system of equation between this guy right here and this guy right here, right? So I have the system y equals square root of s and s equals 3, right? Substitute 3 for s into the first equation. I have y equals square root of 3, right? So the volume is pi times the interval from 0 to this guy right here, root 3, right? Of bigger radius, which is the pink one right here, right? It's going to be s right subtract s left. S right is s equals 3. S left, which means s equals 0 right here. It's going to be right here, right? So I have 3 subtract 0 altogether square minus the smaller radius is going to be right here, right? S right depending on the graph right here, right? It's going to be right here. Y square minus s left, which is s equals 0, right? dy. Now I'm going to simplify this one. It's going to be pi times the integral from 0 to root 3 9 subtract y power of 4 dy, right? Then it's going to be pi times 9y minus 1/5 y to the 5th evaluated from 0 to root 3, right? So substitute root 3 for y, it turns out to be pi times 9 root 3 minus 1 over 5 root 3 altogether power of 5. Substitute 0 for y is going to be 0, right? Now I'm going to simplify this one further, so it turns out to be pi times 9 root 3 minus 9 root 3 over 5, right? And simplify this one further, it turns out to be 36 root 3 pi over 5. This one is the final answer, right? Now let's move on to question B. The axis of revolution is s equals 6, right? Now this is a complete solid, right? So the bigger radius is depending on the graph right here. It could be from here to here. The smaller radius is from here to here, right? Now since you revolve the shaded regions about the line s equals 6, right? So your volume should be in terms of y, right? And the representative rectangles must be perpendicular to the axis of revolution, right? So, and you know that this guy is y equals square root of s, right? So in previous example, we just rewrite this one in terms of y, right? So s equals y squared, right? And the intersection right here is root 3, right? And this one is 0. Now the volume is pi times the integral from 0 to root 3, right? Now bigger radius subtract smaller radius, right? So bigger radius right here, which is s right subtract s left, right? All together square, right? Now s right is s equals 6 right here, right? So it could be 6 subtract s left, which is the curve right here, right? This one. So it could be s equals y squared right here, right? So subtract y squared all together square minus the smaller radius right here, right? S right subtract s left square, right? S right is 6 right here, and s left is 3 right here. This line right here, 3, right? So you have 6 subtract 3 all together square dy, right? So it's going to be pi times the integral from 0 to root 3. Now you're going to use the complete square formula to expand this one. It's going to be a minus b all together square. It's going to be a square minus 2ab plus b square, right? So it's going to be 36 minus 12y squared plus y power 4, right? Now 6 minus 3 equals 3 squared equals 9, so subtract 9. 36 subtract 9 is going to be 27, so I write 27 over here, right? dy. Then it turns out to be pi times 27y, right? Minus 4y cubed, right? Plus 1 over 5 y power 5, right? Evaluated from 0 to root 3, right? Now substitute root 3 for y. It turns out to be pi times 27 root 3 minus 4 root 3 cubed plus 1 over 5 root 3 to the 5th. Alright, so if you simplify further, it turns out to be pi times 27 root 3 minus 12 root 3 plus 9 root 3 over 5 then the final answer must be 84 root 3 times pi over 5. Now let's move on to example number 6. Find the volume of the solid formed by revolving the region bounded by the graphs y equals s squared, y equals 4s minus s squared about the x-axis. First, we need to sketch y equals s squared, right? So s equals 0, y equals 0, right? S equals 1, y equals 1. S equals 2, y equals 4, right? So it could be something like this. Now we need to sketch y equals 4s minus s squared. S equals 0, y equals 0. S equals 1, y equals 3. S equals 2, y equals 4. Alright, so if you sketch it, it's going to be something like this. Then the shaded region should be this guy. Now we need to revolve this one about the x-axis, right? So it could be y equals 0, right? And the x-axis is the axis of revolution, right? Now since you revolve these regions about the x-axis, then the representative rectangles must be perpendicular to the x-axis, right? And the volume should be in terms of x value, right? So let's get a solid. Alright, so the bigger radius is the distance from here to here, right? And the smaller radius is the distance from here to here, right? Now this one is y equals s squared, right? This one is y equals 4s minus s squared, right? So you need to find the intersection between this guy and this guy right here, right? So you need to solve a system of two equations, y equals s squared and y equals 4s minus s squared, right? Then I have s squared right here must be equal to this one right here, right? Then this guy turns out to be 2s squared minus 4s equals 0. Factor 2s out. So it could be s minus 2 equals 0. Now, this one is the 0 product, so I have 2s equals 0, s equals 0, and s minus 2 equals 0, then s equals 2, right? So the lower bound is right here, s equals 0, and the upper bound is right here, s equals 2, which is right here, right? So you have the volume is going to be pi times the interval from 0 to 2. The bigger radius square minus the smaller radius square ds, right? Now the bigger radius, which means y top subtract y bottom, right? So y top is right here, right? Y bottom is the axis of revolution, which is y equals 0 right here, right? So you have pi times the interval from 0 to 2 of 4s minus s squared subtract 0 altogether square subtract, right? Similarly, the smaller radius right here, the y top is right here, right? Y bottom is y equals 0, right? So it's going to be s squared minus 0 altogether square ds, right? So it's going to be pi times the interval from 0 to 2. Now to simplify this one, you're going to use complete square formula, right? So you have a minus b all together square equals a square minus 2ab plus b square, right? So it's going to be 16s square minus 8s cubed plus s power 4, right? And this one turns out to be negative s power 4, right? Now this guy cancel out, right? So I need to erase these two guys right here. and I put ds right here, right? So this guy turns out to be pi times 16 over 3s cubed minus 2s power 4 evaluated from 0 to 2, right? So it's going to be pi times, substitute 2 for s, it could be 8. 8 times 16, it's going to be 128 over 3 minus 16 times 2 is going to be 32, right? So it's going to be 32 pi over 3 is the final answer, right? Now let's move on to question B. Similar to question A, we're going to sketch the figure like this, and then we're going to revolve about the y-axis. So the y-axis is the axis of revolution, right? And we get the regions like this, right? So we need to find the intersection between these two guys right here, right? In the question A, you just solve s equals 0 and s equals 2, right? Now you substitute 0 for s into this equation right here to solve for y, right? So y equals 0 and then y equals 4, right? So since this one you revolve about the y-axis, your volume should be in terms of y, right? So keep that in mind. And your representative rectangles must be perpendicular to the axis of revolution. In other words, that is the y-axis, right? Now, we need to determine which one is the outer radius and which one is the inner radius, right? So volume is pi times the interval from 0 to 4, right? Of r y square minus little r y square dy, right? Now we need to solve these two guys right here in terms of y, right? So I'm gonna put this guy on the side. The first one, y equals s squared, right? Take square root both sides. S equals plus and minus square root of y, right? Now I'm gonna pick s equals square root of y because it's on the right of the y-axis, right? Now I need to solve this one in terms of y, right? So I have y equals 4s minus s squared, right? So this guy is the same thing as I'm going to multiply both sides by -1, so it could be s squared minus 4s equals negative y, right? I'm going to make the left hand side as a complete square. In order to do that, I need to divide the coefficient of the middle terms by 2, and then I'm going to square, right? So I'm going to add 4. The right hand side, I must add 4, right? Now the left hand side becomes a complete square, so it will be s minus 2 all together square. The right hand side is 4 minus y, right? Take square root both sides, you have s minus 2 equals plus and minus square root of 4 minus y, right? And then add 2 both sides of s equals 2 plus and minus square root of 4 minus y, right? Now I'm gonna graph these two guys right here. So I have s equals 2 plus square root of 4 minus y, and s equals 2 minus square root of 4 minus y. Y equals 4, s equals 2. Y equals 0, s equals 4, right? So s equals 2, y equals 4 is going to be right here. S equals 4, y equals 0 is going to be like this, right? Now, y equals 4, s equals 2, and y equals 0, s equals 0, right? So it could be this guy right here. Alright, So if you grab these two guys on that mode, you will see it could be something like this, right? Alright, remember the region is right here. Now, you need to pick this guy, right? Because this one right here is right here, right? So, v equals pi times the interval from 0 to 4, the bigger radius, which is the distance from here to here, and the smaller radius is the distance from here to here, right? So does that mean the parabola right here? We got it right here, right? And it's gonna be square root of y minus 0 altogether squared, right? Because the axis of revolution is the y-axis, which is s equals 0, right? S right subtract s left. S right is this guy. S left is this guy, square, right? Subtract the smaller one, which is this guy right here, right? S right is right here, right? So it will be 2 minus square root of 4 minus y all together square, right? Because you subtract 0, it's going to be this one, right? And don't forget to put the y. Now I need to simplify this one, so it turns out to be pi times the interval from 0 to 4 of y minus 2 minus square root of 4 minus y all together square dy, right? Now to calculate this one, you either calculate by hand or you can use a calculator, right? So I'm gonna use the calculator faster. So I need to hit add calculator, right? Press menu, calculus, number 3, right? The interval from 0 to 4. Don't forget pi in the front, right? Of dy, right? Hit enter. The answer is 16 pi over 3. Alright. Now let's move on to the last one. Revolving the regions about the line y equals 6. So this one is axis of revolution, right? Now we need to sketch the graph. And again, since you revolve these regions about the horizontal line, your volume should be in terms of s, right? So volume is the interval from 0 to 2 right here, right? Pi times the interval from 0 to 2. Bigger radius in terms of s square, subtract the smaller radius in terms of s square ds, right? It's going to be pi times the interval from 0 to 2. The bigger radius is the distance from here to here, right? Which is y top subtract y bottom, right? Y top is right here, y equals 6. Y bottom is this guy right here, right? So y equals s squared. So you have 6 minus s squared all together squared, right? Subtract the inner radius is going to be from here to here, right? And then it's going to be y top subtract y bottom, right? Y top is 6. Y bottom is this guy, right? So it could be right here. 4s, and don't forget to change the sign right here, plus s squared all together square ds, right? Now you can calculate this one by hand or you can use the calculator, right? Alright, so the interval from 0 to 2. After you input the expression, then you're going to hit enter. The answer is 64 pi over 3. We're going to explore topic 8.13, the arc length of a smooth planar curve and distance traveled. This one is the AP Calculus BC topic. Now let's derive the arc length formula. We know that the distance between 2 points on the curve is given by d equals square root of s2 minus s1 square plus y2 minus y1 square, which you learn from geometry, right? So suppose I need to calculate the length of this arc right here, right? Now I have the starting point. It's gonna be A. I'm gonna let this one equals S0, right? And the ending point is gonna be B equal S sub n, right? Now I need to partition this interval into the smaller interval, right? Which is S1, S2, etc. So it could be right here, right? Now, the distance between two consecutive values right here, I call this one delta Si, right? So I have the formula right here, right? Delta Si equals Si subtract Si minus 1, right? For example, I equals 1, I have delta S1 equals S1 subtract S0, right? I equals 2, I have delta S2 equals S2 subtract S1, right? Similarly, I have delta Yi equals Yi subtract Yi minus 1, right? Where Yi is the value of f of Si right here, right? So, if I use the distance formula right here, does that mean I need to calculate the distance from here to here, right? And then I'm going to calculate the distance from here to here, and then from here to here, from here to here, etc. until I reach the last point, right? Now, if I add this guy up, right? So does that mean I'm going to use summation notation? Sum of square root of Si minus 1 square plus Yi minus 1 square, alright, where I goes from 1 to n, right? Now this guy right here actually delta Si, right? This guy actually delta Yi, right? I'm going to multiply the top and bottom by delta Si square, right? So that's why I get this one, right? Now I'm going to split this one into two fractions, right? This guy divided by this guy equals 1. And I'm going to write this one as delta Yi over delta Si all together squared, right? Multiply by delta Si because I'm going to take square root of this one, right? Now, the approximation improves as we take the number of segments to infinity, which means when n approaches infinity, we use more and more subdivisions. We obtain limit of the whole thing right here when n approaches infinity. Alright, now, since f prime of s exists for every single s in the interval s I minus 1 as I, right? The mean value theorem guarantees that there is a number Ci inside this interval such that f prime of Ci equals f of Si minus f of Si minus 1 over Si minus Si minus 1, right? So, f prime of Ci right here is exactly delta Yi over delta Si. Then, this guy right here can be written as L equals limit of the sum when I goes from 1 to n, square root of 1 plus f prime of Ci altogether square. times delta Si, right? When n approaches infinity, right? Now, using the definition of integration, we have this guy right here, right? Alright, definition of arc length. Let the function given by y equals fs represent a smooth curve on the interval a and b. The arc length of the function f between a and b is given by this formula. Similarly, for a smooth curve given by s equals g of y, the arc length of the function g between c and d is given by this formula. Alright, now again, we have the point on the line s1, y1 and s2, y2. Alright, the distance from here to here is given by the formula d equals square root of s2 minus s1 square plus y2 minus y1 altogether square, right? Which is you already learned in geometry. Now, we're going to use calculus to prove this formula. So how do we do it? Now, we're going to start by saying f prime of s. This guy actually the slope of the tangent line, right? It's going to be given by the formula y2 minus y1 over s2 minus s1, right? And this one is the change in y divided by change in s, or rise over run, right? Now, if I square both sides, so what happens? So I have f prime of s all together square. It's going to be y2 minus y1 over s2 minus s1 all together square, right? Now the left endpoint has the coordinate s1, right? The right endpoint has the coordinate s2, right? So by the arc length formula right here, right? We have arc length equals the integral from s1 to s2, right? Square root of 1 plus f prime of s squared, right? The formula already say that. So it could be y2 minus y1 over s2 minus s1 all together square. Alright. Now, number 1 right here can be written as s2 minus s1 over s2 minus s1 all together square, right? And I'm gonna rewrite every single thing else, right? Now, since this guy and this guy have the same denominator, which is s2 minus s1 square, right? So I just rewrite this one in the same denominator, right? Now, keep in mind, the whole thing right here actually a constant, right? Because given right here, it's not variable. Variable right here is just s right here. This one is constant, this one is constant, this one is constant. So keep that in mind, right? Now, so when you take antiderivative of this one, actually you have this one right here multiplied by s, right? S is a variable, this one is constant, right? Remember, for example, if you take antiderivative of 3 ds, it's actually 3s plus c, right? So this one is exactly the same thing, right? So I just copy this one down, evaluate it from s1 to s2, right? And then does that mean you have square root of s2 minus s1 all together square plus y2 minus y1 all together square over s2 minus s1, right? Now you substitute s2 for s, it will be s2, right? And the bottom one right here, subtract s1, right? Substitute s1 for s, you get s1 right here. Now this guy and this guy right here cancel out. That's why you only have this one left. And this one actually the distance formula. We're done, right? Now let's move on to example number 2. Find the arc length with respect to s. Now find the arc length of the graph of y equals s cubed over 6 plus 1 over 2s on the interval 1/2, 2, as shown to the right. Alright, so which means we need to find the length from here to here, right? The left endpoint is right here, 1/2. The right endpoint right here is 2, right? Now I'm going to let f of s equals s cubed over 6 plus 1 over 2s, right? I need to take the derivative of this one, right? So it turns out to be 1/2 s squared minus 1 over 2s squared, right? And then I need to rewrite this one in the same denominator, right? So this guy turns out to be, I know that the LCM of this guy and this guy should be 2s squared, right? So I need to multiply the top and bottom by s squared. It's going to be s power 4, right? The second one is just 1, right? So minus 1 over 2s squared, right? Now I need to square f prime of s. So this guy turns out to be s power 4 minus 1 over 2s squared altogether square, right? Now I'm going to use the complete square formula to expand this one. Remember, a minus b altogether square equals a squared minus 2ab plus b squared, right? So this guy turns out to be s power of 8 minus 2s to the 4 plus 1 over 4s power of 4, right? Now the outline is the integral form 1/2 to 2 square root of 1 plus f prime of s squared, which is this one right here square, right? Now the LCM of this one is going to be 4s power 4, right? So I multiply this guy the top bottom by 4s power 4. So it turns out to be, now if I simplify this one, does that mean I get 2s power 4 right here, right? And then this guy becomes a complete square, right? So it could be equals to the integral form 1/2 to 2 of s power 4 plus 1 altogether square over 4s power 4, right? Don't forget the square root side right here, right? The square root side right here. And then if I take square root, it's going to be the integral form 1/2 to 2s power 4 plus 1, right? I don't need to put this guy inside the absolute value side, right? Because this is always non-negative, right? Over 2s squared, right? If I take square root of this one. Oh, don't forget the s right here. Now I need to do long division, right? So this guy turns out to be the integral form 1/2 to 2 of 1/2 s squared plus 1/2 s power of -2 ds. Now you're going to take antiderivative of this one. It turns out to be 1 over 6s cubed minus 1 over 2s evaluated from 1/2 to 2, right? And substitute 2 for s is going to be 8 over 6 minus 1 over 4, right? Substitute 1/2 for s, it turns out to be 1 over 48 minus 1, right? If you simplify this one, it's going to be 33 over 16. This one is the final answer, right? Now, example number 3, finding arc length with respect to s of y. Alright, so in this situation, I need to calculate this arc length with respect to y. Alright, now I have y minus 1 cubed equal s squared, so I can write s squared equals y minus 1 power of 3, right? Now I'm going to raise to the power of 1/2 both sides. Alright, so what should I have? 2 and 2 right here cancel out, so s equals y minus 1 all together power of 3.5, right? So I'm going to call this one as function g of y, right? Make sure the left hand side only have s, keep that in mind. Now I'm going to take the derivative of this one, so I have g prime of y equals, I'm going to use the power rule, right? So it could be 3.5 times y minus 1 all together power up 3.5 subtract 1 is going to be 1/2, right? And don't forget the chain rule, multiply by this guy prime, but this guy prime right here equals 1, right? Which means you need to multiply by y minus 1 prime, but the derivative of this one equals 1, right? So I don't need to write. Now I need to square both sides, right? So I have g prime of y all together square equals, this one square is going to be 9 over 4. This one square is going to be y minus 1, right? Now the arc length is the interval from, remember this one in terms of y, right? So we need to pick the y coordinate right here, 1, 2, 5, right? 1, 2, 5. Square root of 1 plus g prime of y squared equals 9 over 4 times y minus 1, right? Now I'm going to simplify this one. It turns out to be, multiply this guy, the top bottom by 4. So what should I have? I put this one on the side. 1 plus 9 over 4 times y minus 1, right? So I'm going to multiply this one by 4 on the top and bottom, right? So it could be 4 over 4, right? So it turns out to be 4 plus, distribute this one, it's going to be 9y minus 9 over 4, right? Now it's going to be 9y minus 5 over 4, right? And it's going to be, when you take square root of 4, it turns out to be 2, right? So this guy turns out to be 1/2, like this. Integral from 1 to 5 square root of 9y minus 5 dy, right? Now I'm going to use u substitution, right? So I'm going to let u be square root of 9y minus 5, right? Then I'm going to square both sides, so it could be u square equals 9y minus 5, right? I'm going to take derivative both sides, so it's going to be 2u du equals 9 dy, right? And I need to solve for dy only, right? So I divide both sides by 9, right? So this guy turns out to be 2u over 9 equals dy. Now I need to find the new lower bound and upper bound, right? So y equals 1, upper bound y equals 5. Now the new one, u equals, substitute 1 for y into this one right here. Alright, so we have 9 times 1 equals 9, subtract 5 is going to be 4, square root 4 equals 2, right? Now substitute 5 for y, so it could be 5 times 9, it could be 45, 45 subtract 5 is going to be 40, so it could be square root of 40. Now square root of 40 is the same thing as 2 root 10, right? The new integral becomes 1/2 times the integral from 2 to 2 root 10, right? Now square root of this guy actually u, right? Dy actually this one right here, right? So it could be times 2u over 9 du, right? Now 2 and 2 right here cancel out, right? So you have u squared over 9, right? I bring 9 to the front, right? So it's going to be 1 over 9 times integral from 2 to 2 root 10 u squared du, right? Now I'm going to take anti-derivative of this one. It's going to be u cubed over 3. And then 3 times 9 right here is going to be 27. So 1 over 27 u cube, right? Evaluated from 2 to 2 root 10, right? Now, it's going to be 1 over 27 times 2 root 10 all together cube. Subtract 2 cube, right? And then it's going to be 1 over 27. Simplify this one, 2 cube, it could be 8. Now root 10 cube, it's going to be 10 root 10, so it could be 80 root 10. Now 2 cube, it could be minus 8. And this one is the final answer. Now let's move on to example number 4. We need to calculate the arc length of this guy right here, right? From 0 to pi over 4, right? This one is pi over 2. So you have g of s equals natural log of cosine s, right? So you have g prime of s equals, we're going to use the formula natural log of u derivative. It's going to be u prime over u, right? So u in this situation is going to be cosine of s, right? So take derivative of cosine of s is going to be negative sine of s over cosine of s. It's going to be negative tangent s, right? Now, if you square both sides, so it can be g prime of s all together square equals, this one square equals tangent square of s, right? So the arc length is the interval from 0 to pi over 4, right? Square root of 1 plus g prime of s square, which is tangent square of s ds, right? Now you learn from AB pre-calculus, 1 plus tangent square of s actually secant square of s, right? So this guy turns out to be the interval from 0 to pi over 4 square root of secant square of s ds, right? Now square root of secant square of s actually secant s, right? So it's going to be interval from 0 to pi over 4 secant s ds, right? And antiderivative of secant s ds is going to be natural log of absolute value of secant s plus tangent s evaluated from 0 to pi over 4, right? Now substitute pi over 4 for s. It turns out to be natural log of absolute value of secant of pi over 4 plus tangent of pi over 4, right? Subtract natural log of secant of 0 plus tangent of 0, right? Now observe that secant pi over 4 equals 1 over cosine of pi over 4, right? But cosine of pi over 4 equals root 2 over 2, so it could be 1 over root 2 over 2, right? Take reciprocal of this one, it's going to be 2 over root 2, and it's going to be root 2, right? So this guy turns out to be natural log of absolute value of root 2. Now tangent of pi over 4 equals sine pi over 4 divided by cosine pi over 4, right? But sine pi over 4 and cosine pi over 4, they're both the same thing, right? So when you divide, it's going to be 1, so it could be plus 1, right? Minus secant of 0 equals 1 over cosine of 0, right? But cosine of 0 equals 1, right? So it could be 1 over 1 equals 1, right? So natural log of absolute value of 1 plus tangent of 0 is going to be sine 0 divided by cosine 0. So it could be sine 0 equals 0, cosine 0 equals 1. So it could be 0, right? Now we're going to simplify. Remember, root 2 plus 1 is going to be positive, so you can remove the absolute value side, right? So natural log of root 2 plus 1, right? Now this one is 1 plus 0 equals 1, natural log of 1 equals 0, so the answer is right here, right? Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.